Okay. So it is a pleasure to have this meeting, although it will be much a pleasure if it was in person, face to face. But I hope this will change for the 18 months meeting that we hope to host in Valencia next year about June. We'll discuss this later, okay? Can you hear me now? Because Simo keeps silencing me. Okay, okay. Change to this next slide, please, Simo. Okay. Only some comments on the program, apart from each presentation for each work package leader dealing with the progress made and with any problems with the work package on task. Some things that I want to comment to you is that we don't have this scientific advisory board participating in this meeting today, but already discussed with them that they will come in June, most likely to make it at the same time that the WorkApia meeting that it will be held in Valencia. So all four of them, David Francis, Hatton, also Lucas Miller, and Roger Chetelat, they said that they can come to Valencia in June, attend the pre-meeting, and then eventually the WorkApia meeting, okay? Another thing is that Tatiana, our project officer, cannot make it this time, although he will follow, if we record this, he can follow the progress made. And also, Annette Snigans expresses their interest in the project, and she will probably join us tomorrow for the most specifically, she expressed interest in Work Package 8, the participatory breeding and the citizen science work package, okay? Tomorrow is not in the program yet, but we want to discuss with you the possibility, and this is something we express in the grant agreement, that we have to have at least one management committee meeting or at least once a year, okay? And any ideas you have for tomorrow's workshops are welcome. We can have specific ones or just discuss any problems that we have that we need to solve together. Okay, so Simo, please put me the other presentation, the project in a nutshell, so that I will summarize for all those that joined the project later, not from the very beginning when we put together the proposal, to be aware of what the project is about, the different main aspects of the project. So Simo, can you put me this presentation? Okay. No, it's the next one. The next presentation is the project in a nutshell. That's one. That's the one. Okay, just a few slides that summarizes the main issues that we want to address in this project. Next slide, Simon. Well, this project was funded under this specific goal. It's an innovation action project, so it means that we have to develop some products or processes out of the knowledge that we have developed over the years, and is under the action Genetic Resources and Pre-breeding Committee. And the main idea of this type of project is to enhance the management and the use of genetic resources and implement global commitments in this area. Next slide. The Harnesston project most important asset is that we have an excellent partnership composed of 22 partners in 7 different countries. 12 of them are from academia at the university research centers. 6 are from companies, most small, medium enterprises, and 4 NGOs. Okay, we got funding to support 1,400 person month, and the project allows about 1,400 days. And that means that every day we are funded for 3 people working full-time from the project. So this is an ambitious and well-funded project. It is 7 million from the Horizon 20 program, and 1 additional million coming from companies and from the Taiwan government. Okay, as suggested, just as of yesterday, the gender balance in the project is almost balanced. If you see the previous slide, is 59 versus 56 people in the project, so 59 female, 56 male. Although this changes dramatically between different institutions and groups. Some groups are all male, some others are all female, but in general, we are well balanced. Next slide. The approach that we took in this Harnesstorm is that we have like 3 main groups of activities. One is that we generate information, we generate and centralize the information and tools developed in the project, and also from previous project in a one-stop shop for Tomilo that is localized in Europe with mirrors in Israel. But we also, the main activities will be either in collaboration with farmers or with companies. And this is organized in a kind of ring-fence type of pre-breeding sub-projects in which specific challenges are addressed between academia and companies in a kind of sub-project. And the participatory breeding that is basically done between academia and traditional farmers or farmers anyhow, this will be done also in different countries and working shoulder to shoulder directly, researchers and farmers. And I think this is quite an innovation and the way we propose to do it. And I think this is one of the reasons probably that our project was funded. Next slide. So the one-stop shop, this will be dealt with more detail in the presentation, but basically the idea is that we have information derived from previously funded projects from Traditron, BSOP, TomGem, UTC-PO, UTC-PO. Oh, I'm sorry, you name it. Route to Power, and so on. We also have a community of people interested in the data that are farmers, breeders, researchers. And we also have that we need to a diversity of data from accessions, genotypes, phenotypes, genomics, metabolomics, QTL, GWAS results, all this. And we need to organize this information derived from all these funded projects. We already signed MTAs from these projects to transfer information with, let's say, with our commitment not to publish or not make the information available to everybody before they publish the results. So there will be something that we already agreed on. And so in work package 2, 3, you will realize how this is started to be organized. One of the main things that the call also asks us to produce new visualization tools. And this will be the work of the work package 3. But this is a very important pillar of the project. Next slide. Another important contribution of the project is that we realize that we need to speed, like in any other breeding program, breeding project, is to increase the speed, efficiency, and precision of breeding. And this is the objective of work package 4. And this basically is dividing like in 5. It's reduce generation time, increase recombination rates, then increase our genotyping and resequencing information for the germplasm that we have in the put together. Then to start to see how far we can get with genomic oriented selection to enhance breeding gain, and also to recapitulate what the information we have about materials and populations. And this is basically what we will be doing in work package 4. But this will be, of course, described in more detailed ways. Next slide. The next slide basically summarizes the approach for the different pre-breeding programs. One dealing with diseases, another dealing with climate change, another with fruit quality, which are the main aspects that people are interested in tomato. Basically, is to collect information to, in the case of the disease resistance, because there are emerging new diseases, is to identify new sources for these resistances, for resistance against these pathogens. But in most of the other work packages, it's basically kind of confirmation of the marker to trait association for these disorders or these challenges, then trying to see if we can combine these traits or these markers to produce improved materials, and then to evaluate those materials in different conditions. And this, of course, would be described in more details in work package 5, 6, and 7. Okay. Next slide. Next slide is about the work package 8, basically, and is the participatory breeding and citizen science. And in this case, the work package 8 has like 5 main objectives: is to describe ideotype, and in which we bring together not only breeding companies, or not only scientists or breeding companies, but in this case it will be farmer, consumers, and influential chefs defining what is the best or the ideotypes for them. The other is to produce a repository of genotypes that have an interest or are promising for this interest in citizen science and participatory breeding. This is then to work on the citizen science and participatory plant breeding to improve efficiency, and then 2 main participatory breeding programs that will be described in more detail. One is generally some more basic disease resistances, and the other is to diversify for color and quality. Okay, and I think that's it. What I wanted to tell you for this general idea. Next slide is just summarize the main outcomes expected, apart from specific protocols, QTLs, markers of interest for the companies and interest for the farmers, is that we show that we can build a strong alliance between the different stakeholders for developing knowledge and materials out of the study of the genetic resources, is to build a public repository of information that links accessions and germplasm banks to functional information with state-of-the-art visualization analysis tools. Then to develop tools and materials to increase the speed and precision of breeding, and also to base in all this together to demonstrate the value of genetic resources. And this will be done by developing a series of pre-breeding tomato materials for breeders and farmers. Okay, that's it for the introduction. I think for those of you who have not just went directly into the specific work package because you were hired to this specific work, you now have a more broad perspective on the project. I don't think there is time for question now because this is just for an introduction. So I will just present work package 1, which is coordination and management. If Simon, you can put me the work package 1. We are just on time, 8:45, so I'm doing good. So project management and coordination. This is basically, if you put me the next slide, go to the next slide, Simon. This is basically work for the CSIC, the coordinator and participant. Although all of you, of course, have to contribute to in the management, because most of you are work package leader, and also you have as IEP, PI, you have to manage your own businesses for your institution that we need to put together in the project. So this most of the work for us, but of course, each of you have to do your part. Next slide. The objectives of any management coordination work packages is to provide something that works in terms of management and communication structure, guidance, and support, so that all the partners feel like they are integrated as a whole in a project, and also to implement everything that helps them help the project to start from the beginning and to run smoothly. Okay. Also, we need to be transparent. I mean, this is in all aspects of of living. We need to be, if we want to be happy together, living together, conducting a project, we need to be transparent. So there is a documentation that basically is the grant agreement, the consortium agreement that basically regulates our relationships and among us as partners, but also with the EU. The other objective is to be effective. I mean, to try to make sure that we run the program according to the schedule, and we produce the results that are expected from us. And this, of course, requires coordination, not only by the coordinator institution, but also from each of the members of the consortium, and in the way that is organized by the task leader of the work package leader. And we need to be efficient. I mean, we need to be efficient, mean that we have, although we have quite a good amount of money as funded by the EU, we need to use it wisely and to avoid duplication and try to avoid a waste of time and energy. Next slide. So to do this, we develop a number of tasks for the management and support structure. The idea is that the coordinator provide administrative support, and at the kickoff, we collected a booklet with the most important information, and this was not handed to each of you because we didn't have a face-to-face kickoff, but it was. This is available to all of you through the website. We also have the idea was to produce a password-protected web-based management platform, and it was delivered as a deliverable. And we, as a coordinator, we try to provide support and guidance to all the members, especially those that have less experience in EU projects. And to facilitate communication, we established that we will put together a project website that has been constructed. And we have annual meetings that we, principle, when we wrote the proposal, we said that we will produce progress report annually. But this was because we started with recordings. We think that the best way is to have the records available, and this is available for all of us in the website. So we substitute reports and paper by videos of the project reviews and the project meetings. Next slide. About the contractual issues and the decision-making management, we have all these grant agreement and concession agreement produced. And the consortium agreement is everything that we need to regulate our relationship. It was established at the early beginning of the project. And of course, the coordinator is responsible for the follow-up and for the periodic meetings to organize them and to assess and discuss the project progress. Okay, next slide. We will produce two project progress report in month 18 and 36, and a final one in month 48. But this is mandatory. This is what you need to do. It's mandatory. We have a kickoff. This was already reported and as a deliverable, and we will produce all the reports and also the financial individual report. Have them available for each of you and centralize in the intranet management platform. Next slide. To monitor progress, we have a body, is a management team that basically is located here at the CSIC. We have an executive committee with the coordinators and the co-leader work package and the IPIs from the different institutions. This is wrong here. We need to show that we adhere to the guidelines and national guidelines for ethics and biosafety. This was initially in the grant agreement, but in the proposal, but the commission asked us to introduce a new work package on ethics, and we did that. And we also, for monitoring, we have also a scientific advisory board that is under a confidentiality and non-disclosure agreement participated in the kickoff and will participate in the next meetings and the next academics. Next slide. For the exploitation and management of IP issues, we have a consortium agreement that is the main document that regulates this, and in which we already indicated the way we will do this through material transfer agreement, what is the background information that each of us provided, and what is the rules that regulates the proper industrial protection information. So, and this will be reminded in each meeting that it's important if we feel that we have something that can be protected for the industrial application, we need to do this before we publish, and there will be an incentive program to do this to encourage each partner institution to do this. Okay. There is a confidential agreement whenever we invite somebody to attend the meeting that is not a member of the institution of the project, and we have a group that also look at all these IP issues. That is basically the companies and the Fundación Valenciana and the coordinator. Okay. Next slide. Okay, the administrative support is provided by CSIC. We have in CSIC a number of departments that is related to all the aspects of the project, from the international relationships with the grant services, the financial aspect on the ethics committee, and also for the open access publications. So all these aspects we can provide support at the Spanish from the Spanish headquarters of the CSIC, of the National Research Council, but also locally here at the Institute, financially and also scientifically. The management team basically is Maria Jose and Tony Monfort and myself, but everybody here at the institution will help everybody. The next slide. The activities that we perform in the first 2 months was to organize the kickoff, to have this document, the grant agreement and the consortium agreement ready and submitted to the EU. The grant agreement, the consortium agreement is internal doc, but it's available to all the partners. Okay. We also reported on the kickoff meeting with the appropriate deliverable. Next slide. For the management of the IP results, we put together all this structure, and we have a committee that looks at the dissemination and the protection balance. We have also the researchers and breeding companies and farmers and so on as a team of beneficiaries. But we also introduced the personal data protection, the research data, and the open publication requirement as established and suggested by the Commission. So all this is in place. And you will come in more detail later in Work Package 10. Okay. Next slide. The project portal, okay, is part of this implementing fishing management and support structure. This is a general view, public part of the portal that is available without any passwords or further restrictions to everybody. But next slide. We have a specific part that is the management platform, which is password protected part, that will help us in the management of the project. So each of the groups have access to this management platform. Next slide. And this is already in place. It's an intranet password protected part of our website. It's satisfied all the management needs internally for internal reporting, for monitoring progress at all levels. It's also a repository of documents. And we already have organized a first workshop. This was organized by IMPT to use the Work Package 3 to get familiar with this platform. Next slide. About the bodies, the management. We have the management team, but basically working consultation with the executive committee. as in charge to make sure with the coordinator that the deliverables are uploaded, that the work is continuous as planned, and that we are there, we satisfied all the requirements at the EU and national levels in terms of ethics and biosafety. Next slide. We also established the steering committee or the executive committee. We name it differently in the consortium agreement and the current agreement. This was a mistake that we correct, that is fine. And is composed by the coordinator, the leaders of the work package, and also the principal investigator of each institution. And again, it's similar responsibilities, but basically is to follow the progress of the project at the different level, to look at the intellectual property aspects, also to the ethics and safety, and also to consider and look after the training activities at different levels, workshops and training workshops and training courses. And the idea is to meet at least once a year, and we plan to do this maybe tomorrow. And identify that any issues that may be considered in response maybe to external indication by the scientific advisory board or something. Okay, next slide. The intellectual property management committee basically is coordinated by companies plus Fundación Valenciana, but has to be in close interaction with the previous body that we indicated before, so that we don't publish anything that may compromise IP issues. And there is a number of things also related with this, the material transfer agreement, the non-disclosure agreement that we normally will use every time that is needed. And also one of the main responsibilities also to remind all the partners that we need to, if it's possible, to protect information that is can result in some industrial interest. Next slide. This is our, our scientific advisory board. Lucas Miller, Roger Chettelat, Sam Hatton, and David Francis. That covers the different aspects of the project. Lucas, an expert in database, is the one that developed in SGN and is running it very efficiently. Roger Chettelat has a long-standing experience in genetic resources in tomatoes, the curator of the tomato germplasm banking, that is an important source of variability for many breeders and scientists. And Sam Hatton and David Francis are two breeders working for the academia in the United States, in Florida and in Ohio, and they can provide us good insight and help for the specific pre-breeding progress in the project. Three of them, the one Mark, participated in the kickoff. Some couldn't make it at that time, but the four of them will be more than happy to attend the 18-month meeting in Valencia. Okay, so this is done. And next slide. So all the members of the management bodies have been appointed and are working. The management team, the executive committee, the IP committee, the General Assembly is all of us, and then there are two, the scientific advisory group. There's also some kind of consultation, or there's a stakeholder. So we have also to listen to the stakeholders for their opinions about what we're doing in the project and so on. And this will be described a little bit more in work package 2. Next slide. There were 4 deliverables in the beginning, but the internal reports are not to be produced. So we only have to produce the 18-month, 36 months, and final report that are mandatory. So we are finished basically with the deliverable for this. And they were in month 2 is the project management platform and the kickoff and report and contractual docs. Okay, I want in the next few minutes just to remind you about the basic things about the grant management. So when we have to report and what. So this is a general slide in which we have monitoring, which is along the project, and we have a specific things to do at specific times. Okay, so this has to do with the periodic reports and with the final report. Okay, and then we have to see if there is any deviation from the original grant agreement, which is a contract with the EU, then to produce amendments. And we also have audits. Okay, this is the general thing about this project that we need to do to monitor the project along the 4 years time. And in case we see distortions or deviation from the project, we need to produce amendments that have been to process it and in the interaction with the officer and the EU. Okay. Next slide. When this will happen. So we have this continued reporting, that this is something we report deliverables in month 2, month 4, and we report, we upload, and that's it. And then we have also periodic. In this case, we have, and for our project, we have a report in month 18, and another one in month 36, and another month 48. That is fine. And the report has to be produced 60 days after month 18. Okay, that means that during April and May, this coming 2022, we have to produce this report. And basically, this meeting that we are having today is like a training for this report, not only to monitor the progress that we made in this first year, but also to start to collect information and produce in writing something that we then put together with the progress made in the following 6 months. So that by the time we have to produce the report, we are ready. And also when we have to do the review meeting with the officer and the reviewers, we are in good shape. Okay, so this is like a trend. Next slide. About the continuous reporting. Basically, it's about uploading publications as soon as they are produced. We need you send it to me, we put them in the website of the project, and we upload those. We will come later to what publications have to be uploaded and the open access issues. But also the deliverable. Each deliverable has a specific daytime for delivering and then we have to comply with the deadlines. Okay, and we have to keep updating the summary, the gender table, and all this I do as a coordinator with the input from you. Okay, and this is continuously happening. As soon as they are produced, we report it. Next slide. And we have been doing this. Okay, so we have already uploaded 7 publications that are open access and acknowledge Harenstone. These 2 are the main requirements. We don't upload things that they don't, and we don't acknowledge Harenstone because they are not assumed that they have been produced in any aspect from the project. And then it has to be open access. This is mandatory. We don't report anything that is not open access. Next slide. There were a number of deliverables that we need to produce during the first 12 months. Next slide. Deliverables are outputs that must be produced at a given moment, and milestones are control points that help to monitor progress. And they can be not necessarily associated to a specific deliverable. So milestone 1 is associated with deliverable 1.1 that is uploaded in month 12. As soon as the month 12 deliverable is uploaded, the milestone is achieved. Okay, we have 5 milestones, and we need to be careful because some of them have not been reported as achieved. This is something I need to discuss with some of us. Right. Next slide. But for the deliverables, all the 15 of them were produced and uploaded on time, if not ahead of time. Okay, next slide. So all the 15 we were successful. We managed to produce them on time. And of course, they will be evaluated and accepted when the time comes, normally with the review meeting and in Mount 18. But this can be open. Then the open access publication. This is the list of 7 publications, all acknowledging Harnestone and all reported, all gold or green. They have to be gold or green access. And it takes some time. We have the DOI code is very easy because the system is well established, and as soon as you fill in the DOI, this code that is associated with any publication, all the rest is a number, is just very relatively straightforward. And I do this for you. So this is something you can do for me as soon as you send me this. Okay, thanks. Thanks for all of you 7 that produced this and acknowledge Harnestone. So these were basically UNINA, CSIC, INRA, and IVIA, and UNITUS. All these publications, these were the corresponding institutions for this, but most of them were participated by more than one Harnestone institution or author. Next slide. Again, I come to this point because we have to keep updating this as soon. So I will thank you very much if you report to me any change in the people who are participating in the project, either from your institution or by hiring this person. So I can upload, I can update this piece of information. Currently, I'm missing from 3 of you that did a report on this aspect, and I think the officer always want me or as coordinator to update this regularly. So we are well balanced, as I indicated earlier. Good. Next slide. So about the reporting. Next slide. I already covered this. The reporting. I think this is important just for the preparation for the 18-month report that will come in a few months. Okay. We will, the coordinator and probably all of you will receive an email from the EU indicating, hey, the period is there. You have to start to produce your report. After this, after the 18 months, we have 60 days for reporting to them. And this means to prepare the periodic report that is composed of the scientific technical report, in which the coordinator coordinates this in collaboration with the partners and the work package leader and the task leader. But is the most important part, sometimes it comes late, is the financial statements from each of the participating institutions, because this is something tricky and we can provide help. And for those of you who are experienced partners in EU funded projects, it's fine, but for the new ones, maybe it requires some assistance. But anyhow, this reporting has to be produced as a single package. That means that the technical scientific report has to go together with the financial. So we cannot submit the scientific report and then the financials. So it's important to be in touch, to reach out for our financial administration and the department to ask them to produce with our help, of course, to produce the financial report. So after these 60 days, we can, as deadline, we report to the EU, and then we have 90 days for the review and payment. Okay, so and for this, all these documents are used to assess the progress, and the reviewers will write a report in 30 days, and in 90 days as a total. And then if there is changes to be made because the reviewer want more information or something, or the financial report needs changes, we have maximum 30 days. Because of the COVID restriction, this is done now, until now, through internet, through the web, but eventually we could have, and this is the plan, to have in June, the review report meeting with the reviewers and the officers here in Bolivia. Next slide. So we need to have what is going to be checked in the review meeting. It will be the deliverables. Were delivered on time, were uploaded on time, the content of the deliverables, what the reviewers find as suitable and correct. The periodic report with the scientific technical part, written by the coordinator in collaboration with the partners, of course, and the financial part that is based on the financial statement for the partners and consolidated by the financial administration of the coordinator institution. For the final report, this is not the time now. This will come in some more time. Next slide. Some aspects about the deliverables that I think we already fulfilled this. There has to be self-explanatory, contain detailed information, and for the cases in which the deliverables are public, we don't need to be too much technical about the deliverable, because it has to be public. It is understood that it has to be readable and clear for a non-technical or scientific background. So if we do this, and the milestone the same, so if we do good reporting, it's good, because then there won't be a rejection by the reviewer. It will be accepted, and then we will go smoothly to the next step. We get the next piece of funding, and we can continue our project without any delay. Okay. Also, we need to review the risk management, something that we already put in the grant agreement. We just need to review this. If in the case of the COVID, or in the case of something happened that we are not was not planned, we need to change these mitigation measures and the risk that eventually may come, and then we need to update this. Okay. It's good that we also have a consortium agreement, that is this internal document that regulates our relationships. And it's good that the periodic report contains all the work done, including those from the non-EU funded partners, like Taiwan in this case. Partners are our colleagues from University of Taiwan or from World Bank. Have to also to report to add to the report to this consolidated report, and also to explain any deviation. Okay. But what mostly concerns me sometimes is the financial statement that has to be correct, because this is where we normally fail, because we are scientists, we are not financial administrators, but we need, for those institutions that have the expertise, no question that they will do a good job, but we need to be careful and work together with them to make sure that all the cost will be accepted. Otherwise, it will start to go back and forth and reject the financial statements and so on. Next slide. Who will participate in this is the coordinator, is the single point for the interaction with the EU. The project officer, in this case is Tatiana Talarico, is different from the one that helped us in the grant agreement. Okay, so it's a different one, but it's also a very nice one. Not much experience in this field, but just move on this in REA. Has 2 or 3 years experience only, I think. And I had several conversations with her. She's there to help, and I'm pretty sure she wants to get involved. For instance, I have a meeting with a webinar in DiveSeek with the coordinator from 5 other, and my email inviting her to participate attend this didn't reach her on time, so he couldn't make it. She couldn't make it, and she expressed that she wants to be aware of everything that goes with the project that she can be interested in. So I don't know yet the financial officer, but because I knew the previous one, but there has been some rearrangement inside REA, so we have a new one. So, and then the reviewers. These are the expert reviewers. They're normally 2 people, sometimes 3, that monitor the progress. They are normally allocated they're suggested by the project officer, but normally we have to confirm whether we have any conflict of interest. So by the time this comes, I will let you know, and you express whether you have any conflict of interest of any of the potential reviewers. We inform the officer. If everything goes well, it's normally they also, the reviewers normally collaborate actively to make the project better, not to put the stakes on the wheels. Next slide. Okay, so financial statement, all the parties insert the data, the technical report, we insert the data in the webs, in the appropriate places. We sign, submit, and the coordinator submit this. Okay? For the financial statement, the same. We check the data, and then the coordinator will submit the data on the same with the technical report. But I need your, of course, the feedback from your institution and for you, for both. Okay, next slide. Okay, the project review is done by the project officer with the assistance of 2 experts normally. It could also include a policy session in which the policy officer, in this case, Annette or whoever is at the time, can attend, and also the review meeting in which we are the participants, and the date, the duration, and the agenda we have to agree with the officer. The review project, the review report, we have to produce this in after month 18. No, the review report is what the REA produces after reading our report. Okay. In 30 days after, we have to reply within 30 days, and there is no major objection. There's no need to reply. So we need to be sure that we produce a good report, that we address all the issues, and any delay is indicated to justify it or reported earlier to the officer, and so she's aware of it. Okay. Okay. So if everything goes good, then the payment is launched and everything goes smooth. Next slide. And that's it, because I wanted to talk you about the open access and data management, but we can do this in the workshops at the end of the tomorrow session. And I think the best is that if you have any questions for this work package, normally there are no questions, but if there are questions, we can have a couple of minutes for this. Is any questions for me in this reporting or the management structure on the activities, and any issue that you want to say, please ask. And if not, we proceed with the next work package.
I have just a comment on the management platform.
Yes.
Just to record that normally all the PIs receive the login and password to access to the platform, and PIs can add users from their institution. And also they will find in this platform all the deliverables, all the partner presentations, and all the presentations of the previous meeting. And after also this annual meeting, we will put all the files in the platform. So if people have problem to connect, just send us an email, and we can also organize another training session for the management platform. And from now, they, as you said, Tony, they can start to review, to prepare the review, to add text and ask partners. So work package leaders can ask the partners involved on each work package to start to make the review.
Yes, this is important because this platform is very nice. I think it can help a lot to produce the report that is due after month 18. So each of those that are enabled to do this because they have access. And an important issue is also that we need to update the partner and each with a list of email, all the people involved. So people, Simo, maybe you can circulate the Excel file for all the partners institutions and for all the participants in the institution, so that people who have been hired on the project add their names and the email contact. So when we send the general address, email address, they are also included. Okay, that's important. But the most important thing, as Simo indicated, is that people start to use this management platform that is very helpful to produce the task reports the work package report and the total report, okay, at the different levels. Any other question or comment? So if not, then we move to the next work package. These are already work package with specific content, not general management and coordination, but work done in the frame of the project. Work package 2, it will be Ascensión Ciruelo from PSIX. Work package 2, if you can load up this.
Please, yes, please, Simo.
Yes.
Could you let us share our presentation?
Yes, yes. Because I did not receive it yesterday, so I will allow people want to present to do it directly from their computer. Okay. Now, normally you can.
Okay. Can you see our screen? Fine. Yes. Hello, good morning, everyone. As Johnny has already commented, Work Package 2 deals with societal issues, stakeholders engagement, project dissemination, as well as legislation and public acceptance. This work package is led by CETAEX in Spain and Fundación Cajamar, also in Spain. And the main objective of this work package is to ensure a consistent dissemination and communication, ensuring optimal visibility and a wide outreach to all the relevant stakeholders, including also receiving feedback from them and to provide training for using GenRes to different stakeholders and in consideration of the ethics and the legislation. Even though CETAEX and Fundación Cajamar are the leaders of this work package, it's essential the participation and contribution of the rest of the partners, as we all know. To reach the general objective of this package, 5 different objectives have been identified and the corresponding tasks to achieve them. The first one is the communication. Communication means creating visibility and encouraging the project outreach. The second one is dissemination of the results to target stakeholders as well as the scientific community. The third one is the training in terms of generating new skill workforce, especially for the seed industry and academia, but also for other stakeholders in the whole tomato fruit food chain. The fourth one is fostering innovation capacity as well as the exploitation of the results. And last but not least is identifying, evaluating, and proposing solutions to possible bottlenecks that could derive from ethics or legislation on the use of GenRes and registration varieties. To achieve these objectives, several tasks with the corresponding activities have been performed. The first one is the constitution of the project communication team. This was created in the very early months of the project, and it is composed of the Work Package 2 leaders as well as a representative of other Work Package. Concretely, the French National Institute in Toulouse and the Polytechnic University of Valencia. CT will be in charge of the project communication and all the activities related to dissemination, guidance that assure quality content. This has been materialized in a milestone called Basic Communication Concept. This is a document with the basic rules of communication of the project in order to meet all the planned communication objectives. The second one task deals with communication activities. The first one is the communication toolkit that is a basic that was developed in the very beginning of the project, and is a communication toolkit including the design of a logo and the basic templates. Later, informative brochure and newsletter with the action of the projects have already been designed. And the next, the newsletter, we already have a newsletter, and the next one will be developed in 3 months. Another important material is the audio visual. The project, as you all know, and has been already commented, has a public project website. In this website, the project website and social media. Then in this web page, 8 videos has been already uploaded to explain key features of several work packages. It's already being developed a promotional video of the whole project that is always that is being developed at the moment. In addition, in the web page, we have developed a form to subscribe to the newsletter, so to try to increase the stakeholders, the stakeholder range. As already commented, we have the newsletter. The newsletter is an important tool to communicate activities developed in a certain period. Important as well is the social media strategy. We have a Twitter account where all the information and retweeted content is achieved. So should you make any related post, please mention it. Another important issue, another important item is the YouTube channel. The YouTube channel Harnestone is the project video repository and is used to publish it on the web as well as in the social media. How do we generate the content in social media? Well, we have established more or less a protocol that is known by all the partners. So any picture, video, or date is transferred to the work package leaders that put it in the correct place. The third important task, and already mentioned, is the open access publication. Management team led by Tony in CECIT encourages the open access publications of the results of the project in peer-reviewed journals and at international conferences. So each partner is aware of the obligation to make this publication open access, and the publicity is already available. Up to now, as Tony has already commented, there are 7 publications that can be found in the EU portal of the project. Besides, it is foreseen to develop what is called project fact sheet. This project fact sheet includes the features, objective, and expected result in order to present the project to different stakeholders, but with non-technical profile. At present, is being under preparation. And then we have what we call technical fact sheets that is also produced, but already adapted to a specific target audience profiles. These profiles are academia members and breeding companies, producers, attending agronomic behavior. We have then the distribution company and supermarkets paying special attention to storage and port harvest conditions. And the last one is consumer and catering, focus on organoleptic characteristics and final consumption. The leader of this task is Fundación Cajamar, but all participants contribute periodically. The fourth task identified to communicate and to disseminate better the Cornerstone project is the networking activities. With this task, the objective is to foster a networking within and outside the scientific community and the connection with other related initiatives at international level. So Cornerstone partners attending specific sessions or vice versa, the same location or different. Up to now, Cornerstone partners have participated in 11 events. Task leader is ZS, which compiles in a database all these events. And in addition, the partners have already contacted relevant stakeholders from the agri-food sectors and have already sent them the newsletter. All participants send identified stakeholders to be included in this database. Project newsletters are then sent to all desks, including and increasing the Cornerstone one. And then here, what the importance of what Tony has already commented. Tony, if you want to re-explain.
This is in relation. This on the previous slide.
Yes.
In relation with some suggestion, but even at the level of the grant call, the call that was the result was the grant. Our grant is that we need to establish interaction with other funded projects under the same topic or same call. So in the previous slide, if you move back in one slide, Simon, can you go back one slide? Yes, that's one. So these are projects that were funded under the same or similar call about the same time. So some of them are maybe 1 year into the project, some of them not yet started recently, and so on. But this increased agent, breeding value, gene for olive, gene rest, bleach, for genius, and so on. These are projects that basically they also are under the genetic resources umbrella. And the idea is that all these projects should aim to increase the use of genetic resources to produce and improve breeding or conservation. So we got together, I started this collaboration, and then we also have a webinar that was organized by DiveSeek, in which most of the people of the coordinators of this 6 or 7 project participated by explaining what the project was about, where we're standing at the project, where we're beginning at the middle, but with the idea that to identify commonalities or possibilities of interactions. And the next slide is a slide that I produced that also need of course, your feedback, because I identified that things coming out from our project could be of also interest for other similar projects, like the one in the previous table. Like, for instance, the functionalities, the structure, or the tools for the gene to trait information in the one-stop shop for tomato could be also applied for strawberry, which is another of the breeding programs of supported by the same call, or for any other, okay? Because being under the same call means that the expected impacts and everything else is shared between all the projects. So some of the projects in different crops, they address similar things. So, and having a centralized information database is something that is shared between the projects. So I logically indicated, okay, maybe we have to talk. Maybe we have to have similar structure. Maybe we have to have similar functionality. Maybe we can share the visualization tools that we don't develop similar things in different projects, but we share the information. We can develop more without duplicating efforts. Another thing that was of interest for some of the projects from Gym for Olive, because Olive has all this juvenility period. So for breeding, olive is not as easy for annual crops. And in case of tomato, we can have 2, 3, 4 cycles in a year. We aim to have more. And we are doing some biotech approaches. So I thought, well, maybe they are interested in similar approaches in fruit trees or in other of the products. So sharing the strategy to increase speed, efficiency, and precision of breeding. Maybe some identified genes that increase in harnestome eventually, that increase recombination efficiency may work in other crops. So I thought this was another point of interaction. And then the sharing knowledge about traits is also important, especially for in some of these projects, they also work in fruits. Of course, quality of the fruit is an important aspect. So in tomato, there has been a model for many fruit crops. Could also be harnestome could be a model of information source for other projects under the same call, at least for the fruit quality QTLs or markers and so on. And then some of these other projects also share the interest in participatory breeding, and some of the partners in Work Package 8 are aware of that and already sharing information and in contact with all the tasks in these other programs. So, and this I also indicated in this DiveSeek seminar that we can also have it. But this deserves a specific meeting with them and maybe to invite some of the people from these other projects to our project. So, but I think the EU wants us to have this interaction, okay? Of course, sharing the dissemination of research strategy is something that we can share, especially we can share stakeholders between the different projects so they can attend the several meetings at the same in different locations. So I think there is quite a nice opportunity for interaction between the EU projects funded under the same call. And this is a list of things that items that I thought that was a good idea, a starting point. But of course, we need also to get to agree within Harnestome that the people working on the functionalities in the one-stop shop in Harnestome are willing to collaborate with other work packages in other projects. Also the same for the strategies of increase. Are we willing to share this or not? Are we wanting to share the strategy? We want to have conversation with them. We need to this was my opinion, but of course, I cannot do this myself alone. I mean, this is something we have to agree. Okay. Next.
Yes. Thank you. Thank you.
Okay.
Just a moment, please. Yes. Well, the next task identified is the capacity building, meaning the training of relevant stakeholders. The aim of this task is to maximize the impact through the celebration of several capacity building workshops that target specific groups. One of them is shaped as Advanced Training School on the use of data found in public repositories of genetic resources for breeding, new tools for genotyping and breeding, and this would be directed to plant breeders, PH doctors, and postdoc researchers. And then a second type of workshop, it would be the training school on browsing genres, what it is called Finding My Ideal Tomato, and address to farmers, cooks, and the general public. This task lasts the last half of the project, and the partners involved are the Italian ENEA, the French National Polytechnic Toulouse of Toulouse, sorry, the Polytechnic University of Valencia, the CSIC as coordinator, and the Hebrew University of Jerusalem. The last task identified in this work package is directly to clarify the regulation on the use and the registration of genres in plant innovation, both vegetable variety rights and patents. First of all, a thorough review has been made of the main legal issues of the use and registration of genres, vegetable varieties and plant materials, and related to transfer of genres in plant material within and outside the partnership. So a compilation of the regulation on this subject, both at international level and especially European regulations, and at the leading countries level with a focus in the terms of use, registration, and transfer. This compilation will be updated regularly as part of the observatory of the current legislation, and this has been shown in the first deliverable 2.5 that is carried out in this first year, that states the initial state of the art in legislation. Lately, a legal news section will be developed and timely updated in the Harnestone webpage, including compilation of news and relevant legal information on this matter. As already commented, the first milestone achieved was carried out with the development of basic communication concept. And regarding the concrete deliverables of this work package, as already has been shown, we have fulfilled the first fifth, and in time, and will be included in the corresponding periodic report. So to have a snapshot of this work package, the activities, and what we have done and what it is planned to do in the next year, we have summarized in this slide. The creation was carried out by these participants. And it is important to remark that this communication team has periodic internal communication. The second one is the communication toolkit, where we have already said that logo and templates have been designed. Then we have we've foreseen to carry out the second newsletter. Audiovisual material of the corresponding work packages have already been uploaded in the webpage, and a whole on the visual presentation of the project is under issue. Then we have a brochure that is foreseen and is being designed, as well as the fact sheets. External project website is active and continuously updated, as well as the Harnestone Twitter account and the YouTube channel of the project. So you know that from the work package to leaders, we encourage all partners to create content to fit Twitter, webpage, and YouTube. So here you have the address contact of the two people involved in this compilation. The activities, another activities planned is the project's open access publication status to keep on updated, to create a database of specialized contents that will be implemented during the whole project life. And finally, through our review of the main legal issues, will be carried out and the use of registration of genres and vegetable varieties in plants. These activities will be carried out throughout the whole project, of course. And that's all from our part. Thank you very much.
Thank you, Ascensión. I think it would be nice if we can monitor because we would be asked about the consequences of our outreach and activities. For instance, how many, if we published something in a local newspaper, or there is an interview in a radio, local radio, national radio, what is the impact? How many people normally listen to these news sections, things like that. I think having a record of the impact of the different activities is important. Not only whether a publication has reflections on the national news at 9 p.m. Yeah, and this means an audience of several millions. It's not the same as if it has a reflection in a very local radio station. These things I think that you want us also to report, and this is important.
Suggestion.
It will be
in the same way.
Of this.
In the same way we do with the, how do you call el número de las cosas? In the social media.
Yeah. And I think some of the partners already established like a protocol for Twitter, news, to report to Twitter. Like, I don't know, they can produce some news, for instance, interviews with this farmer or something, and they don't deliver at the time it's the news produced. So, but they program it so that they have a Twitter, something to say on Twitter every week or every other week. So I think we have to encourage that we have like a plan for releasing short news, maybe not necessarily high impact news, but something that keep people aware that there's a project called Harnestone that is working, that is producing and having an impact. And I think this is good, that somehow you remind people to get organized. I think Work Packet 8 is doing a nice job in this. I think me as a coordinator, as a, let's say, representative of Harnestone as a whole, I'm trying my best to report on, to tell people here in Spain and in Argentina the other day, in Cuba the other day, about the tomato importance and the quality and the importance of breeding and so on. Sometimes putting myself in a difficult situation, like trying to say that the most popular chef in Argentina is wrong when he produces a video that has a high impact in the local news, that just by squeezing a tomato and showing that it's full of liquid, this indicates that the modern breeds of tomato have no taste because they have lots of juice. This was he was reporting on. Yes, huge impact. So, and then I got a call from the Argentinian newspaper and TV, say, can you comment on that? So the best thing to do is say no. But I think it's important that we report on what we do, and we get out of our, let's say, comfort area in which we just don't get out of the lab. And I think some people are, like in Work Packet 8, are doing this, and they're having an impact. So the impact is, of course, is measured on the terms for the project of how much innovation we transfer to the sector in terms of varieties, markers, and so on, but also in this, because the society needs to know what we're doing. Mm-hmm. And you have a relevant role here, pushing us to get out of our labs to do something else.
So from here, we encourage you all partners to be active in these terms and to supply us and to contribute in any way to the communication and the dissemination activities.
So can I make a suggestion?
Of course.
That is related to communication. If people who agree to switch on the camera, that we will be able to take a group picture that we can use for social media.
It's a good suggestion.
Can I say something?
Yes.
For work packages, Tony has mentioned that in work packages, we have some strategy about communication into the social media. Yes, we establish a calendar in which each week, one of the partners have to produce a brief news. It's a video or a short sentence, some photographs about some things that we do just for dissemination. I will explain a little more tomorrow in work packages presentation.
Fine. It's a good suggestion. Thank you.
So again, 1 minute, and I will do a screen shot of of the computer, just to let the other partners who would like to switch on the camera. Okay. Just few seconds, maybe. Okay, very good.
Good.
Many people are coming, so I will count until 3 that we can make a good smile for the people. So 1, 2, 3. Cheers.
Yes. Thank you, Simo.
Good. Okay.
May I ask something to Tony? It's also about communication. You mentioned that 18 months, the meeting will be in person in Valencia. Could you suggest how many days and which part of June, earlier, later, middle? So at least get an idea to block the agenda.
Julian, thanks for asking me this, but I was to address this tomorrow at the end of the session.
Good.
Because there are different possibilities to merge because we have, in June, we have the EUCARPIA meeting.
Yeah.
We have probably some of the people of the Scientific Advisory Board coming for the EUCARPIA meeting. It could be nice maybe, and also many participants in Harveston may be attending the EUCARPIA meeting. So if we finally do it in person and in Valencia, and the EUCARPIA meeting is going to be in Valencia, why not to put them either before or right after? That was the proposal. How many days? This is the review meeting. So we can have, and the review meeting is something that is not everybody meets with the reviewers and the officer. Only the work package leader and the PIs from the institution. So 22 people at the most, okay, with the reviewers. And this is, let's say, a review meeting with the officers, something just to give them the best impression possible that we are doing what we are doing on track and things are going fine and so on, so that it can produce a good report and we get the next payment and we continue business as usual. But also to show them if something goes wrong, because we cannot hide things underneath the carpet. But my idea is that if we do a review meeting one day and we have to agree deal with the officer in the day, then we can have 1 or 2 days before, we can squeeze in a 2 days meeting in which we can participate like today, but locally, in person, in which we can discuss more scientific content and also a small preparation of the next day meeting with the officer and the reviewer. And this could be 2 days.
Yeah.
So in total, if we manage to put them together with EUCARPIA, could be a whole week. EUCARPIA 3 or 4 days, but 3 days with the pre-meeting and the review meeting of the Harveston. But about the beginning of June. But this is something that we can propose to do to the officer, and if he agrees on this day, then we squeeze it and we organize it. We tell the officer, the Scientific Advisory Board, we agree on the days with all of you, and then we proceed from there.
Yeah, thanks,
okay,
Tony.
tomorrow we'll discuss this at the end, okay?
Yeah.
Can I say something about
Yes.
the work package 2 activities? It's only a comment, as tomorrow we will talk about the starting activities for task 8.3, which is dealing with citizen science experiments. So we are moving to organize things in the best way. And we realize that we will need a lot of interaction with Work Package 2, because we will need to disseminate tutorials, forms, informations, and so on through the website. So this is just a warning for for the colleagues, and in the next days, because time is short, we will move a lot on this direction. So we will need to implement in the website
Yes.
this material, which is needed for communication, and precisely the material should be translated into local languages, because we cannot do it with English, only with the English version. So it could be a little bit more complicated
Yes.
than other informations.
Thank you, Andrea. My colleague is putting in the chat her contact, her direct contact, so we can discuss this information you need.
Yeah, I think for this that you need support from the Harnestone website. This is something that has to be dealt with the communication team that includes Work Package 3, CIMO.
Yes.
So to
Yes.
get the best possible way, so that people have not to look at this in a second or third link within the website, but maybe try to put it up front, like in the first picture that we have on the website. Say, okay, we are now focusing on these activities, so the people who goes there immediately can get all the questionnaires and all the activities that you want to do. So, but we need to go to work not just Work Package 2, but also interaction with Work Package 3, because this has interaction with the website structure and capabilities. Okay. Any other question for Work Package 2, but for Ascensión or Pilar? Yeah, an important thing that also you indicated that is important, because we need to enlarge the stakeholder groups. We have so far members. So far we have many, but are mostly from Spain. We have some other from Europe, from other countries in Europe. But we need to increase the stakeholder groups by adding, I don't know, companies from the food and drink industry, things like that. We contacted some of them, but they couldn't make it, from Brussels or from the Netherlands. But we need the help from you partners from other countries that is not Spain, to increase our stakeholder group that eventually may be an interest in the outcomes of the project or in the activities of the project. And we can invite them to participate in the meetings. They can listen to specific sections of the meeting for specifically designed for them, so that they are aware of what we are doing. Okay, but we need to increase this list. We already have a large list, don't we, Ascensión and Pilar?
Yes, we share with you the folder, but I agree with you that we have to increase not only in the number, but in the kind of stakeholders and the nationality, of course.
Yeah. So we have so far a very nice interaction with the stakeholder group that represents the EU-funded projects. This, we are very much in line. I guess we are also very good in representing the industrial sector and the producers in Spain, but we also need this, maybe in Italy, but we need more from France, the Netherlands, from all, at least from the countries that where we have partners in Harnestone.
Yes.
And we should also aim to partners outside.
Mm-hmm.
Okay. And also a comment on some of the activities that we were to develop in this Work Package 2 that had to do with the ethics and so on, moved to Work Package 10, because they were initially we thought that we could make it without going to specific ethics Work Package, but the EU the Commission just find that we need a specific Work Package. slides, and then we
No, it's a,
so
I
that we
remember.
move there. Okay.
Yes.
Okay. So more questions for ThetaX, for Work Package 2, sorry. If not, then I think we can stop now. We take a break, and we can. What time is it? So we are 1 minute after 10. So we come back in 15 minutes. So we are good because we are running ahead of time. Does that mean we can have an early lunch? I know that having a lunch at 1:30 p.m. for some of you is late. For us, is early, but most likely we can finish 5 minutes or 15 minutes before. So by 1, maybe we are done. So by 1 p.m. So let's go now have a coffee and we'll reconvene here in 15 minutes.
Yeah.
Okay, Simo, can you arrange this to be, so we get back to the meeting in 15 minutes. So 10:17 around
Okay. Okay.
that. Okay. Go. Okay. So we mute and close the
Have been done with contacts and relevant publications and dataset authorships. There are also a Germplasm template for the accessions aligned to be included in the database, that include also the pedigree and some data based on multi-crop passport descriptors and some attributes that are inherent characteristic to the lines or the accession that should be this line contains this mutation. This is the characteristic of this line. Also for phenotyping data that includes the samples, the traits, the scales where the trait was recorded, and observations done in each one of the accessions or the replicates. The samples also include templates for DNA or metabolomics recorded data and the type of the protocol. Of course, the fields there are fields that are mandatory, recommended, and optional, because not all the works people have all the information, but some fields should be mandatory to feed the database. Also for metabolomic, this is a specific or transcriptomic data. The transcriptomic data still we don't have the template, but with the input of Tom Express, we can mix the both templates and includes some requirements for the metabolomic standards for reporting data, but is more or less similar to the phenotypic data. Then we have a template for genotyping MAPA that includes the maps or the accessions, the crosses that we do for the maps or the markers, the variants and the samples. We have prepared for this moment three genotyping platforms, that is the Traviton, and the SoulCap in 2 versions of the map. So people just need to include some metadata associated to how they filter data and the variant set. It's not necessary to include more. Then for QTL and GWAS that are linked to phenotypic and genotypic study. And for breeding still, we are thinking in how to include this data and also to upload images linked to accessions, to traits, observation, and to the fields. Next. For example, this is an example of how the templates look like, that some of the information at the end will be filled by a form and the other just uploading tabs. And in the case, for example, if you want to upload a GWAS study, you need to upload first information about the program, that is the project where the study is associated, then the trial, that is the question that you want to answer. In this case, for example, I want to identify regions in the genomes associated in Traditon to the phenotypic variation. So this is the name of the trial. Then there are the studies that are the different experiments conducted in different locations. The GenPlus with all the information about the accessions we have. Next. Okay. Then the samples, where the samples were recorded for genotyping or for metabolomics, the trait description, and then the observations that we have in this in each accession for these traits. Next. There is the genotyping information about these accessions, how we genotype, and which are the variant set, and then the results of the GWAS study with the statistics. So all of this is the information. This is an example. There are different templates if you want to plot phenotyping data, or just a complete study. I think that is
okay. So I would like to mention that this is an important part of that corresponds to the beginning of the project, and if we have clean templates and good templates, I think we will have maybe it will be easy to work after and to don't train with us some problems in the tables. So thank you Clara and David that work hardly to clean these tables and make them useful. Okay, so now we will move to task 2. So the first task is to prepare the collection of the data, and task 2 is to start to connect all this data into a relational database. Okay, and so this is what we have to deliver in month 18. So in March, so we have to deliver the relational database. And in parallel, we have to work on the web-based portal. So the frontal server to allow the user to connect to the data, to fetch the data, to show, to visualize, and to analyze. So task 2 will mainly focus on building the database and also building the web portal. Okay, so now I will let David, our informatician in my team, that will talk us how he thinks to build this. So go David, please.
Can you hear me?
Yes.
Yes. Yes. Hello, everybody. Talking about the Work Package 3 project pipeline. So we have this pipeline. This pipeline is mainly composed of 3 parts. We have on the left the relational database. That is a multi-omics data. The data are basically the information coming from the information collected from task 3.1. In this information, we have a lot of templates, just as Clara has just shown you. We have a lot of templates, and from these templates, we are going to produce entities. Entities are just tables to be stored in the database, but we cannot store exactly the information the way they are in the templates. That's why we have to formalize the information in a database implementation logic. We are working on this part right now. And after this part is ready, once the database is built, we will be moving to the web application. The web application is a portal where user can access directly to the database through a browser. They will have a link such as, let's say, honestom.eu. People, they will visit this link and they can create their user account with some privileges, because we tend also to make the data accessible under a certain criteria, certain condition, which means a person with a specific privilege can access certain data. We will build the web application for that, so that user can access, can manage the accessions, they can search, they can add, they can retrieve, and also we will have a section for user to upload directly data in bulk. And after, to make this project communicable with some other projects such as Tom Express, that is a project in which we have already some data analysis tools and visualization tools ready, we will build API to make this project communicable with Tom Express and also with Breedbase, which is a breeding software, a breeding management software. So to achieve this goal, we have a time frame. The time frame is the deadline we have to achieve this. For each task, we have a deadline. For example, to be ready with the database, we have to deliver this by month 18. And for the web interface, we have to produce the deliverable by month 24. And for the visualization tools, we have to do so by month 36. Now, talking about the database, for some of you who are not, who don't have a computer science background, I would like to show in the next slide the entities on which we are working now. We are working with those entities. That's an overview. For example, we have programs, we have traits, we have studies, we have marker, we have observations, we have germplasms, we have pedigree. So that's all of the entities we are working from the templates. We need to introduce the entities into the database, but not the way they are in the templates, but just we have to do so in a database logic implementation. And for the next slide, I will let you with Clara that will explain in more details with the Honest Tom gateway.
Okay, this is the idea that we had about what the gateway should have. So it's a web interface with a user management account that has data says for managing and adding program trials, phenotyping, genotyping, association studies. You can upload data and you can create, for example, crossing experiments for start to follow and organize it and to store all the data of breeding programs. The idea is that the gateway has some searching or tools to search accessions or trials and all the information you can find in the accession is to search. There are different tools, could be and to link to the seed banks where the accessions comes to ask to order accessions. There could be also an analysis tool for visualization, like histograms, bar plots, or several tools that are for range and interactive searching for several traits or different experiments, comparing experiments, or PCA, ANOVA, correlation networks, stability and multi-environment. Some of these tools comes from the Breedbase, GWAS, genome selection. There are also data mining tools linked to the other platforms, like if you want to analyze some RNA-seq data that you have done, you can analyze linking to the Tom Express and with the tools that Tom Express has, or linking to other platforms for MapMan or Cytoscape. Also link the genome browser, the data, the variants that we have to the genome browser, and also implement some tracks with the QTL of the GWAS to visualize the position where the variants we have identified are in the genome. Also to search by ontologies or search experiments by climatic condition if we have this information. Also, there are several visualizing tools that we develop or partners ask, so we can try to find this tool in another platforms or try to develop. And of course, you can download the results or download the tables to reuse this data in other analysis or analyzing your own software if you want. It's done.
Okay, thank you. Okay, so now let's move to the visualization tools. So the idea is to implement or to improve existing tools, as I said. So we started with the platform Tom Express to improve some tools. So here you can see for people who don't know this platform. So the idea of this platform is to start with RNA-seq raw data. So the whole idea is to unify the whole set of RNA-seq data through a pipeline that make all this data comparable and and that we can compare at the same moment. So the idea is to map, to download data, so maybe from as I said, from the project. So already some partners of Harnesstorm send us some RNA-seq data. So we have this pipeline built that clean the data and align them. So now what is new from in the from the previous months is that now we aligned again everything onto that we can call maybe reference genomes. As you know, now the actual reference genome is Heinz, but in our lab we also generated a reference genome of microtome. Why microtome? Because it's widely used now in many labs as a model just to do fast functional genomics, because as you know it's a small plant and we can easily work with. So now we have a good reference genome of it, and we align everything also on this reference genome that we annotated also in our lab. So after everything is counted, and our colleague and also partner in a member of Harnesstorm, it's Eli Maza, that do the whole normalization of the whole set of data, and our also bioinformatician that work also in the project, Anis Jari, that build this database and that we can have access through the web portal. And also it's important to mention that Pierre Frasse from our lab also, he did huge work to re-annotate the sample, starting from the publications to give homogeneous name of each sample for the whole samples in the project. So just now what is new is that now we moved to 1,200 samples that cover 46 RNA-seq projects all around the world, and it covers 477 conditions. And inside you can have plant development, abiotic stress, biotic stress, roots, leaves, pollen, and trichomes also, some many mutants. So you can at the same time with your favorite gene ask to show his expression and what you can have as an output. So this is the web page now, the new one that is in a beta version. Okay, so now when it will be ready very soon to be online for as open access. So at the beginning you can choose if you want to search in using microtome as a reference genome or Heinz as a reference genome. You put your name of your genes and you choose the conditions, the species, and the category of the experiment, and you can generate figures like this. So now we are really in the visualization tools, one of the goal of Harnesstorm. So here now you have new tools that we improved. Some of them are new, some of them are an improvement of the previous one. So you can make a bar plot. You can also we have also a GBrowse now, so you can see on the GBrowse the plot, the annotation, and also you can do some correlation study. And we implemented new tools of this correlation study because we can make discovery with this kind of tools. So that's it for the visualization tools. So others, as said, Clara will come in the next period. So we still have time to develop them. So now we'll move to work to task 4 that deal mainly with breeding tools, not visualization tool, but now we move to breeding tools like to make GWAS, to search for QTLs, to identify traits. So these tools. So we have two categories. So I will start by the first one, and I will after let Yaniv present Phenom-1 breeding tools. So we decided after discussion in the work package group and also with our project advisor, Lucas Miller from SGN. So we decided to use breed-based management software as a breed, because it contains many breeding tools and documentation is good and it's open access, it's free. And we have also the help of the SGN team. And so the idea is to start from here and if there is something to improve, we will improve it and we will adapt it for tomato data coming from tomato. So this is ongoing. David have installed it successfully. And now we will, like for SGN did for cassava, we will do a tomato breed-based platform by also adding some other tools. So this, okay. So this is ongoing. And now I will move to task 5. So this concerns the private pre-breeding platform. And I will let Yaniv talk you more about what they did at Phenom.
Thank you, Simon. Just a moment, let me share the screen.
I have your slides if you want to.
Okay. Can you see my screen? Maybe I will just show them
okay.
from my computer.
Okay.
Can you see them?
So I will stop my presentation. Okay.
Okay. Just can you confirm? Can you see my screen?
Yes.
Okay. In work package 3, one of the tools that we will use is Phenom 1, which is a software that we develop here in Phenom Networks. It's used by today more than 100 breeding companies. It's really, it's based on breeding requirements that we get from companies. So sometimes it's different than the requirements of researchers and the academic studies, but many things are aligned and are similar. First, I will say what is available in our system, and second, how we want to extend and integrate it with the other tools that Simon David mentioned before. So Phenom 1 is a web-based system for managing breeding data, including germplasm development, field map, field designs, and experimental designs, collecting observations using a mobile application or just by uploading from Excel files. We have some statistical analysis and visualization tools of phenotypic data, and also some of the genotyping data, such as the QTL and genome-wide association studies. So all of these tools will be available for the project, and basically the system will host all the data that we generate here, and also data that was generated in other projects, but is relevant to us. So very quick screenshots from here about options related to browsing data, displaying data, searching and querying data. We have upload tools that allow you to load data from Excel files. We have a very extensive user permissions where you can decide for each given data set whether it is shared only with few specific users, or at some point it can be made completely public. So all of this is already available, and that's kind of it's basically a database that will help us to host the data, share the raw data and the analysis and the results, and so on. So some of the statistical analysis and visualization tools include analysis of phenotypes, like the kind of common ones, clustering, comparing genotype by environments, even combining ability tools. And also we also have statistical methods to analyze QTL and genome-wide association studies that are available. So it's not only hosting the data, but also provide analysis capabilities. And in particular, Phen-O-One already implements what is called BRAPIDS breeding APIs, and again, it's a kind of a technical term. Just to mention, API, it's application programming interface. It's basically commands that allow to communicate with our system by external system. It's basically a way to create integrations with external systems. And BRAPID, the breeding API, it's kind of an open source specification of the APIs of how to communicate with breeding database. We already have some support of BRAPID. We plan during the course of this project to extend significantly the support of BRAPID. And the purpose is really to integrate the system to other tools that are available. So there's no single system or tool that will meet all the requirements, okay? Phen-O-One is basically designed for requirements of breeders, not necessarily of researchers. Sometimes the requirements are different, sometimes they are very similar. So it's clear that we need to extend the capabilities of Phen-O-One. We cannot provide answers for all the requirements that you may have. For this, as I mentioned, we have APIs that allow integration to other systems. In particular, we will integrate Phen-O-One with BreedBase that David showed just a few moments ago, and with other tools that will be considered as necessary. And the idea is that the synchronization will be done automatically. So if a user add data to Phen-O-One, it will be, for example, automatically synchronized to the BreedBase. So user will have both options to use options in Phen-O-One or in BreedBase, for example, for the visualizations. And by the way, I realize now that I forgot the first slide here. So here in the first slide, there's a list of available data resources that will be integrated to the HonorStorm Gateway. It starts with the GWT Sol, which is another project, and we already have a lot of data over there. It will be loaded to the HonorStorm or synchronized or integrated to the HonorStorm Gateway. We will also generate some data during the course of the project in Work Package 4, Work Package 7, Work Package 5. These data can be uploaded from Excel files using the upload wizards that we already have. In addition, we have some other resources like Traditome, and also there we have data that's already ready for upload to the HonorStorm Gateway. Also data coming from Bresso will be uploaded to HonorStorm Gateway. And also data from TomGem, which is yet another project. Tom Express is kind of a different integration. Here we will have integration through API. So it's not just, we don't want to necessarily duplicate the data in Tom Express, just link users to use the tools that they are offering. So we basically consolidate data from many other projects into a single gateway, and we extend the capabilities to other visualization tools and statistical methods like Breedbase, like Tom Express, so the users will have a lot of options and they will see always the same data. Okay, so so this is a major part of this work package, to really consolidate all the data from many different resources, to extend the analysis and visualization capabilities as much as possible. And yeah, I think this is going to be a major effort of us. Yeah, and I think by this I'm finished. And Simo, we can move back to you.
Okay. So just to select some significant outputs, as Clara showed with David, they identified and they worked hard on the templates for files, so they are ready now. Most of them are ready, and we already produced some visualization tools for RNA-seq data, as I show you for Tom Express. And also, as Yaniv said, they have already an instance of Phenom-1 Harness-Tom already online. Okay, and we are working on APIs like BRAPI to make everything communicating together. So this is already no, it's not. So what we will do in the coming months is to continue to work on the implementation of the visualization tools, and for this we use also, as Yaniv said, BRAPI, and make also communication with Breedbase software and within management program. And also we plan to, when we will have something ready with data inside and some tools working, to organize a training school or training course in the frame of the Harness-Tom work package 2 and 1. Okay, so this is just an example of some BRAPI that mentioned already Yaniv. So here you have some examples. When we will have the data into the database, we can plot figures regarding the accessions. We can do some filtering. We can plot ontologies. We have some comparison tools, some pedigree, viewer. So it seems to be nice when everything will be working. We maybe in 1 year, because this is the time that we fix it in the frame of the project, we can have something fine to offer to all of you. So this has been already presented by Yaniv. So I will move to the deliverable expected in this work package. So we already produce deliverable number 1. Okay, so we have the coming one is in month 18. So we are on time. So we don't see any deviation. And the others, as I said, also are coming. We will have in total 5 deliverables. So milestones have been achieved, as have been shown by Tony. Okay, and for dissemination and training, as I said, we will organize some training for the community, but also some members of the partners working on work package 3 have followed some training, like Clara and Eden. So they had this the training on the Elixir Fondue Dataton. So it was an interesting one, I think, to see how to what are the best practice when we work with a lot of data and heterogeneous data. So that's it. So the page of problem and deviation is empty. So we hope that it will remain empty until the end of of the project. Thank you very much, and we will be happy, Yaniv and me, if you have any question.
Yeah, this is Tony. My question is, to what extent we are duplicating the efforts in Phenom and in the Harvestone Gateway. And I have also a question about who is filling and who is the transfer of the information from the different projects into the different platforms, because there is, of course, templates produced, but who is going to fill those templates? This is in a specific work package. I understand that for the GWAS and QTL, some people will do that, or for the UTP Sol, for the Traditom, for the TomRes, somebody has to follow the templates and do the work, okay? And to what extent these templates, once they're filled, they can satisfy both platforms, Phenom and the Harvestone Gateway. Are we doing this in twice or two different ways? One template will satisfy both.
Simo, can I take this question?
Yes.
Okay, so I'll start with the second question. Who's responsible on uploading the data? So we will be responsible on uploading data to Phenom-1. So the list of resources that I showed, like Traditom, Bresso, G2P Sol, all of them. Of course, together with a group of Simo, we are responsible in uploading the data to get it from there and upload it to our platform. So we'll do it together, but we will take responsibility on this. Now, going back to the first question, is it going to be duplication? So, or is there a need to upload it again to another platform? So the idea is no, there's no need, because part of the work is the integration. So, for example, David created the Breed-based instance database. Basically, it's a separate system than Phenom-1. But once we create an integration, automatic synchronization between Phenom-1 and Breed-based, for example, that's a purpose of the work. When we load the data to Phenom-1, it will be automatically synced to Breed-based, so no need to upload it again. And the same is true for perhaps other tools that we will use. Once we use something, we will make sure that there's an automatic integration. So you only need to load it once to a single platform. Yeah, does that answer the question?
I agree. Okay. Is there any other question? Okay.
I have a question for the TomExpress, because TomExpress is useful platform for sure to see where the gene is expressed in a reference genome that normally people use. People are doing profiling on Moneymaker or MAT2 or specific mutants, but this doesn't fit much onto this wide germplasm approach. I mean, and so in most of the cases, the database will have lots of genotypes or accessions and a number of traits for those accessions. While in the case of genomics or the RNA expression, mostly will be in one or two genetic backgrounds or a mutant versus a wild type. So I don't know to what extent you indicated, Simo, that so far TomExpress has data for a large number of experiments.
Yes.
And you will be mapping against the reads, against the microtome and against Heinz, which is a nice academic exercise. But at the end, you have several physiological conditions, but most of them are represented for one or two varieties that are the reference experimental genetic background. So,
But as you know, all the cultivars are very close. They when you do mapping, you succeed almost to map 90% of the reads on Heinz or on microtome. So I think
no, my concern is not about the mapping. I think the mapping is fine. It's about this information is about expression in one or two genetic backgrounds. I don't in another in accession. Name it, and different number may be different because a mutant is something you don't know. So the integration of this very large amount of data for a large number of genes, but only in a few genetic backgrounds, is what is different from the rest of the data. That is a limited number of phenotypes, but in a large number of genotypes, which is basically what we are getting from Traditome or GTP-Sol.
But for example, if you are doing a cross, you want to analyze the expression in the parent and in the line that has the introgression. So this is part of a crossing project, and just two varieties, and you can analyze this, and you can have this story in the database, the lines and the maps and the expression, all of this, and you can analyze this data.
Yeah, but that's for the future. You have to produce, still to produce this RNA-seq data from the parentals of the cross. But so far, the information, the static information that we have so far is very limited, and in my opinion, dramatically different from what we have for other phenotypes and genotypes.
Yeah. Can I answer? Can I try to answer this?
Okay.
So yeah, the TomExpress really meant for gene expression data, which is very different than what you typically have in breeding databases. It's different data types. And I think the purpose, our purpose is to, gene expression data should be kept in TomExpress. It's very suitable for this. While other related breeding data should be kept in BreedBase, in Phenom-1 system. So we are not going to duplicate gene expression, or we are not going to put gene expression in breeding database. It doesn't make sense. Gene expression will go to TomExpress, and that's my idea on this.
Yeah, the idea is in the same platform. You can move easily to TomExpress. You can move easily to BreedBase, easily to Phenom. If you have if you have your set of genes that you find, maybe we're using RNA-seq data, you want to go more, look in which region they are, and to do some focus on the locus. The idea is to keep the user in the same gateway, and to choose the tool that he wants to use to go further.
Yeah, because these are different tools that answer completely different questions. If the question related to comparing different genes and their expressions, go to TomExpress. If you have other questions related to traits and germplasm, go to breeding database. It's kind of two separate domains, I would say.
So there is Mathilde and Giovanni. Maybe you can take Mathilde first and Giovanni after.
Okay, thank you. Yes, I have three questions. One of understanding, because I do not clearly understand, for instance, in Work Package 7, we are doing marker-assisted backcrosses. Should we put the data into Phenom-1 as long as they are private data, because they are in the process of marker-assisted backcrosses, and then they will go into the web once they will be public? Is that it? Or
so yeah, okay. So you will be able to upload it to Phenom-1 privately and only share them among ourselves or among some users that you decide. And in the future, once we decide, we can make it completely public.
okay.
It will be synchronized with the BreedBase tool that can offer other tools and that are complementary to Phenom-1, or the same tools but can give you other view of the result, and you use the one that you prefer. Yeah,
Okay.
as Yaniv said, we will build a connection between the two databases. So all data that will be in Phenom will be also in a BRIDbase. So
In the Harnestone database, we are planning to put a public release date for the data set we upload. Not all the data will be public, just the data that is published or the author of the data set says, okay, this can be public. This other, no, this is the release date, is the 12th of December of the 22 or the 20. This is one of the conditions. So there are different privileges. So you can see some data that is public. You can see this data set or this experiment because it's part that you are the manager of this experiment. No, Pierre?
okay.
Yeah, okay. And so two other questions more for the future. One is, how do you see the future of the Harnestone portal and database after the end of Harnestone? Because we have developed many databases in previous large projects and which are no more available or very difficult to find. So is there any specific
Yeah, I can answer that because in conversation with Lucas, and if we go through BRIDbase, most of that can be part of BRIDbase, which has a continuation in the future, as far as we can say.
Okay, and also, as you know, Mathilde, the server is at Genotool Buinfo, so it's a public
infrastructure, but if there are many data, then you have to pay for keeping the data in the platform. So once you will not have any budget, it might be more difficult.
For 5 years, and the commitment in the project is to keep the data at least 5 years after the project.
Okay.
So for this, we will find a solution with Tony, I think.
And a last question. Do you plan to have a pangenome? Which is the future for our genome studies?
Okay, so normally it's not funded by the project, Harnestone, but we must have a side project to work on this, to hire people to do this. Yeah, I think it will be interesting to have it. Yeah.
Yeah, because it is developing very fast.
Yes.
Yeah. Thank you.
Thank you. So Giovanni.
Hi. Maybe I can answer the last question of Mathilde. The GDP Solar core collection has been resequenced to 20x, so that's sort of a pangenome. It's not very high quality, but it's there for everyone to use in this project. And the important thing is that unlike previous pangenomes, all the seeds of the various accessions are available. Then I have a question regarding TOMEXpress, which is what version of the tomato genome does it align the RNA-seq data to?
It's the last one. I will tell you. I will open quickly.
4.1.
I will tell you in few seconds. Okay.
It's the one by the.
I think it's the one that has been fixed because they published one, but after they did some fix of some errors.
Okay, if you can just look it up. And the last question is the micro.
It's the 4.1. 4.1.
Okay, and the last one is the microtome assembly publicly available?
Yes. Yes.
Okay, it's on the.
Yeah, I can send you the link. I can send you.
Okay, good. Thanks.
Okay, so very good. So we can make the junction with you, Giovanni, because you are the next speaker.
Yes. Okay, so let me try to.
Maybe it's better that you share your screen and to control your slides, maybe.
Okay, as you wish. I was thinking that you were going to show them, but I can do it as well. So
the idea to have them also is to put them on the management platform, so everybody can access to the
open.
presentations.
Let me open it. So let me share my screen. You see my screen?
Yes.
Yes.
Okay. So work package 4. So I'm Giovanni Giuliano. I work at the Italian Energy Agency, and my co-leader in this work package is Mina Formisano from Semiorto Cementi. So the work package 4 is tools to increase the speed, efficiency, and precision of breeding. So it's a technological work package, if you wish, like a little bit like work package 3, only that it deals mostly in wet experiments rather than in silico experiments. And the partners involved is, besides us, that we lead the work package, are Hebrew University with a very important contribution in terms of person months, and then FSIC, INRA, UPV, UNINA, and with lower, and of course, Semiorto, who co-leads the work package, and then with lower contributions, ENSA and UNITUS. So what are the objectives of this work package? Is develop tools. The first objective is develop tools for cost-effective, high-throughput genotyping. The second one is shortening the time needed to verify market traits associations. So seed to seed, basically, seed to seed generation time. Then tools to increase recombination rates and reduce linkage drag. That's an alternative way to improve the efficiency of breeding, because breeding is all about crosses and selecting progeny. So either you shorten generation time or you increase recombination rate. The net result in both cases is that you speed up the breeding process. Develop efficient genomic selection tools and protocols. As you know, genomic selection has become very important in the last 10 years or so. It is very, very used in animal breeding, and it has had tremendous success in animal breeding, like selection for milk yields in cows. So genomic selection basically works on the assumption that the potential for a quantitative trait is dispersed all over the genome. It's controlled by many, many minor QTLs, and basically it tries to predict how you can put all these genome regions together to improve the quantitative trait that you're interested in. And then develop and characterize breeding materials and improve our understanding of loci underlying major agronomic traits. So let's start with task 4.1, methods to reduce generation time. The partners involved are ourselves, Semiorto, FSIC, and UPV. And the approaches are either physiological, so for instance, pot size or fertilization or water deprivation, or light quantity and quality, genetic, use of mutants, editing, virus-induced gene silencing, or overexpression of modulators of flowering, or grafting onto rootstocks containing overexpressing positive regulators. And then an extra approach that can result in shortening of the reproduction cycle is Ember Rescue, which shortens, it's able to shorten by about 15 days to 25 days. The deliverables are, one is focused on environmental, so genetic independent treatments to shorten generation time in month 24, genetic approaches on month 36, and then an industrially applicable protocol and genotypes on month 48 that combine the best protocols developed in the first two deliverables. And we decided to work for this task on 3 genotypes: Moneymaker, which is a salad type indeterminate; M82, which is a processing time determinate; and Microtome, which is an ornamental determinate dwarf plant. It's not commercially used other than ornamentally, but it's a very nice model system for tomato genetics. And we distributed the seeds, we grew them, and basically the result is in different locations and different growth situations. Basically, both Moneymaker and M82 have a generation time seed to seed of about 4 months. This means 3 generations per year. And we are aiming in this work package, in this task, to bring it down to 3 to 4. So there's a lot of work to do. SIC is a little bit shorter, and now we grow them in a growth chamber. SIC, they grow in greenhouse with additional lighting. And UPV, I don't know if it is the same as SIC, but the time to flowering is 45 to 46 days. So it's very comparable in the 2 varieties. And that's the first sort of surprise, because one, as I said, is indeterminate, does not carry the SP mutation. The other one is determinate. It carries the SP mutation, as Microtome does. And as you see, Microtome is much shorter. So there is something else in Microtome that really decreases a lot generation time. And that would be very interesting to find out what it is. And if it can be uncoupled from the dwarf size of the plant, which obviously does not make it very interesting for breeding. What has been done to now, UPV is performing an experiment to evaluate the effect of pot size on the earliness of flowering. And they didn't get fruits yet, but it's very evident from this picture that the biggest pot, the better the plant is doing. And this is not surprising. But what is surprising, at least to me, is that it flowers earlier. So unlike I would have expected, maybe some others would have expected, stressing the plant with small pots, which is an approach that works very, very well, for instance, in Graminaceae, in wheat. You do single seed descent. You grow them in very dense, and they go very fast, and they produce a single seed. And this approach does not seem to work in tomato. So bigger pots, which is not good news, because bigger pots is more space needed, etc., etc. And we will see if this is confirmed at the fruit and seed production level. This is the experiment that's ongoing right now. And the next conditions is to be tested by UPV are water stress, high phosphorus concentrations, potassium, and low temperature for 8 days after cotyledon's expansion. Another genetic approach that has been taken by SIC is to overexpress a positive regulator of flowering, which is the FT gene. And to do this, they used transient expression using a virus vector. So they infected plants. And you have the result, the net result is 1 week of acceleration of generation time in MoneyMaker and M82 out of about 4 months, as we saw, and about 5 days of acceleration in Microtom. So this works in both Microtom and MoneyMaker and M82. So I would say this phenotype is SP independent because these different genotypes carry or do not carry the SP mutation. And the second important thing is when you treat with a virus plant is you want the virus not to go to the next generation because you want the next generation to be virus-free, and this has been confirmed by SIC. Just one pool of 4 seeds out of 280 seeds was positive to the virus. And this is probably not interesting for this project. Actually, it is interesting for this project. They also developed stable transgenic lines overexpressing a DFT that could be used as rootstocks for grafting to them science that you need to accelerate flowering, since the FT is a diffusible factor, so it could accelerate flowering in science. It has been shown to do this in different plants. And then a complementary approach by SIC is to silence the negative regulators of flowering, which are SP, and it's the other family members, SP family members. So the idea is if you take an indeterminate plant like MoneyMaker, does not carry SP mutations, probably these silencing of this gene might bring some acceleration of flowering. Although we saw before that MoneyMaker and M82 do not differ so much in generation time. So no significant effects on Microtom. I'm not surprised on this because I expect Microtom to carry an SP mutation. Of course, I don't know what's the allelic status of SP5G is. That would be interesting to check. And they are checking it in MoneyMaker, which is the obvious candidate because it does not carry the SP mutation. So the question is, will it accelerate the flowering and fruiting time in MoneyMaker? And they also using gene editing, they developed stable knockout lines for SP5G for both genes in tomato. It would be interesting to see if these could also be used as rootstocks, because knocking them out might result in an increase of the phlorygen. So these could maybe could be also useful as rootstocks. We'll see. Methods to increase the combination rates. So the approaches are, again, physiological and physical, like recombinogenic chemicals, and then genetics. The idea is to overexpress or to silence modulators of recombination in collaboration with SIC. And then that's a line of research that started in G2P Sol, was started by Huji. Huji has identified a series of recombinogenic loci in bills, in Bacros inbred lines from Solanum penellia, and it's actively characterizing them. And then there was a tissue culture approach for producing double haploid plants, but that's been canceled after discussions between the partners. So again, the system that we chose to use is use a Lycopersicum times Pimpinellifolium hybrid, which has presumably a lot of heterozygosity. It was a little bit difficult to germinate. We optimized the germination. It flowers rather early. It's an indeterminate plant with heterostylic flowers, but flowers in just 108 days. Now, hence, it flowers earlier than Moneymaker. And basically, we grew it and we extracted DNA to see if it is indeed heterozygous. So when we confirm that, we will start the experiments to check if we can increase recombination rate by any physiological or genetic or physical chemical approach. The other approach is by Hebrew University. Hebrew University has introgressed a series of chromosomal segments from Solanum pennellii, and basically using genotyping with SPETs has shown that there are regions on the chromosome that are very recombinogenic, like here and here. And these are sort of hotspots for recombination. So the question is, and they have identified QDLs in these bills that control recombination rate. And one question I'm personally, one aspect I'm personally not aware of is whether these QDLs are cis-acting or trans-acting. So are they proteins that increase recombination rate everywhere in the chromosome, or are they just fragments of Pennellii DNA that increase recombination locally? And that's a question I would like to ask Danny, if we can answer this in the discussion. And basically what Danny is going to do is he will take bills with high and low recombination, and he has already crossed them to Cheesmaniae, and he wants to genotype F2, and basically he is going to confirm that these, as I understood, the purpose of this experiment is exactly to verify whether these QDLs are transacting. And the other experiment is they cross them to introgression lines from Solanum lycopersicoides. These introgressions are extremely large and they don't recombine with tomato. And basically the hope is that these QDLs will break the suppression of recombination. So the recombination will go up, and these large lycopersicoides introgressions will be broken. And then this will be done both by genotyping and by visual screening, by crossing to collections of morphological markers. So did I say everything correctly, Danny, or is there anything you want to add?
No, that's it, Giovanni, thanks.
Okay, so genotyping and resequencing. Basically, when we wrote the project, we said we would do low density by amplicon sequencing, high density, medium density by SPET, and then very high density by luminary sequencing. And the SPET panels are developed. We have 160,000 markers to select from. These have been developed in G2PSO. There is a low density panel that is available, but we might need to increase its size. and then Illumina resequencing. So let me give you an overview of this. Amplicon sequencing, you can go for 100 to 1,000 SNPs. That's the sweet spot where you get a lot of return for your money. So if you do, let's say, 1536 samples for 100 SNPs, it's $4.50. For 384 SNPs is $5.25 per sample. And for 1,000 SNPs is $9.50 per sample. And that is very convenient because it includes DNA extraction. So what you do is you just take leaf discs and ship them to the company, and they do everything for you. The drawback is that you cannot design these SNPs everywhere on the genome because you need 2 conserved regions flanking the SNP, and that's not available everywhere. Especially, it's probably not going to work with wild species introgressions, which have a lot of SNPs around the main SNP. But having said that, there is already a panel available with 384 SNPs, which is derived from SOLCAP. So that's ready to use today. And if we want to increase this panel, go bring it up to say 1,000 SNPs, some partners have expressed the need to include some additional markers in the panels. The setup for each additional SNP is about $20, the setup cost. So the question is, will we go on with the present panel? Will we add a few more SNPs to this panel before starting? And as I said before, we have now about, as you will see, about 6 million SNPs to choose from the resequencing of the G2P-SOL collection. SPET worked for us very well for G2P-SOL. We did about 15,000 genotypes with the SPET, 5,000 markers, and the cost was about €17 per sample for this 15,000. But here, the news is that costs have gone up. So if we want to do 6K, the lowest you can get is 24 euros per sample. And if you want to do 18,000 markers, the cost is 33 euros per sample. And these are the minimum number of samples you have to have. And now let's go to sequencing. Sequencing, you can do, the good thing about sequencing is very flexible. You can do 1x coverage, and this gives you millions of SNPs. And of course, you get a lot of missing data. But there are bioinformatic methods to fill the gaps, and that's called imputation. So basically, if you go for 1x plus imputation, you get millions of SNPs. About half of them are real, high quality. About another half is imputed, is derived from the tomato haplotypes. So when you resequence a large panel, you know that the SNP A is usually in cis with SNP B. So if you're missing data for your SNP B in your resequencing 1x, you impute it assuming that that's what it is based on the linkage disequilibrium in the tomato germplasm. So 1x plus imputation is 32 euros. So it's very competitive with SPETs. So my orientation would be to go for 1x for imputation for everything that's medium sized, medium density, because you get many more SNPs, and because for about the same amount of money. It's not targeted, but you get them all over the genome, while the SPET is targeted. 5x is about 60 euros per sample, and 20x is about 135 euros in sample. And we are continuously working with the companies to bring this price further down, but that's the best we got to them for the moment. And of course, both for SPET and for this, the partners will need to prepare their own DNA. And we have sent them informations on the protocols on how to do it. So basically, these are the requests that we have gotten up to now. We have gotten a request for 20x sequencing, 5x resequencing. We have gotten a request for both SPET and 1x resequencing, and I put everything under medium density. And we have gotten requests for low density. And if you sum this up with the present costs, it comes up to 114,000 euros, which is about more than double what we have budgeted for this activity. So we have to find a way either to prioritize samples or to increase the budget for this activity. I think that some of this 5x could go either to medium density. For instance, maybe the MAGIC population could go to 1x plus imputation. And some of this 20x could become 10x, because 10x is sort of the sweet spot for sequencing parentals. When you do 1x imputation in a, let's say, recombinant inbred population, you need good sequencing of the parentals. And usually the minimum you need is 10x. And also for doing Kamer-based duos, which is another very fashionable and efficient way to do duos, 10x is what is needed. So we might change this 20x into 10x and limit it to a minimum, and then split this 5x partly into 10x and partly into 1x plus imputation, and sort it out a little bit. And then we still have to decide whether this 384 is sufficient or we have to develop further markers. Genomic-oriented selection to enhance breeding gain, that's by UNINA, and others participate to this task. And the definition of prediction model, the deliverable is month 36, definition of prediction models for yield, SSC, and heat tolerance. So basically, you have a data set, a training data set, for which you have both genotype data and phenotype data. And basically, from this data set, UNINA did a little bit of simulation and saw what is the minimum number of SNPs that give a reasonable accuracy. And when they used 14,000, they got this accuracy here. Then 2,000 random, they got this accuracy here. 278 on genes, the accuracy goes up again. So you can use relatively few SNPs provided they are on gene-rich regions. They did this also on recombinant inbred lines, and the third data set is another set of recombinant inbred lines. And basically, the work the model is working. The SNPs have been, the minimum number of SNPs has been sort of identified, and so they are waiting for data from other test populations like the G2P Sol and Traditum to further this prediction model and improve the predictions. And regarding this, the good news is that the data on the G2P Sol core collection are about to arrive. So the G2P Sol core collection is composed of 342 domesticated accessions and 41 wilds, and over 150 phenotypes for this collection have been scored in 4 randomized block field trials at UPV and the CRI, AVRDC, and HUGI, the all partners of this project. Over 400 fruit metabolites were scored in single double replication from the UPV field trial, and all these successions have been resequenced 20x, and all the SNPs were extracted. For the whole collection, there are about 32 million high-quality SNPs and 2.5 million indels. For Solanum lycopersicum, so the domesticated part of the collection, which you do GWAS, and you presumably do also genomic prediction, we have 6.4 million SNPs. So we have plenty. We can flood this task with SNPs both on genes and out of genes. And task 4.5, materials and populations to increase breeding efficiency. This has not yet started, and basically it will collect all the various collections, the G2P Sol, which is all available presently at 2 locations. One is UPV and the other one is AVRDC. The Tradidom collection, which I believe is also available at UPV. Then core collection of cherry tomatoes at INRA, RIL populations, and the BIL population by Dani, and MAGIC populations that are being developed by UPV. UPV is, I forgot to mention this, but is developing a very important MAGIC population from 8 parentals. It's domesticated and Cerasiformis, if I'm not mistaken. And this will start later on. So the planned activities for the next 12 months are SIG is going to repeat the experiments with VIX and overexpression. And in Moneymaker and other genotypes with different flowering times, and they will characterize the transgenic lines that might be used as rootstocks to improve, to decrease flowering time in science. We will perform low density and medium density genotyping and resequencing of all available samples, but we will have to sort of find an agreement on how to go on with all these requests. How do we cope with these requests? Are we only responsible for this task financially? Are there funds that other partners have received for this objective? Then we will verify generation time in different photoperiod light qualities, verify recombination rates in the Pimpi-Lick hybrid under different physiological conditions and physical chemical treatments, and provide resequencing metabolomic data to task 4.4 for genomic selection. Dani's lab will test the reducibility of the recombination QDL. Unina will test methods for identifying the minimum SNP panel density required to perform genomic selection. They will evaluate the procedure for integrating marker-assisted selection data in genomic selection and explore unrelated data sets, G2P Sol, which, as I said, is almost ready, and Tradidom, which I believe is ready for building up a permanent training set. UPV, evaluate physiological conditions time, water stress, high phosphorus, high potassium, low temperature, and embryo rescue to reduce generation time, and they will extract DNA from their MAGIC population and submit for genotyping and analyze the data. ENSA does not have any activities planned for the next 12 months, and I still need a reply from INRAE, Semiorto, and Unitus, probably because I just sent the PowerPoint just 2 days ago in the evening. There is a dissemination activity that was published just at the beginning of the project by UNINA. And deviations, we decided that we would eliminate from task point 1 mutant-based approaches because they are not useful industrially. I mean, at each generation, if the mutant is recessive, you lose the characteristic and you have to recross it, etc., etc. And also doubled haploids, and for dominant mutants, that's also not very desirable because the dominant mutants have some negative agronomic traits that you don't want to have in the final hybrid or in the final accession, in the final variety. And then the double haploids from task 4.2 was, we also agreed that we would eliminate this approach, and this will be addressed in the amendments. And thank you very much for the attention.
Okay, I think some of the issues that you raised, Giovanni, for the steering committee, we can discuss this, the budget for how to do this additional genotyping needs, how to address them either by individual partners, they uncovering their own expenses, and do just.
And my question is, are these the only ones? Because, you know, this is what arrived in the first 12 months of the project.
Yes.
What will happen if there are requests further on that arise as the project goes on?
Yes.
How can we accommodate those?
Yeah, but this we can discuss tomorrow after the sessions meeting with the executive, the steering committee, if possible. Yeah. And then we can also discuss all these amendments issues. Okay, that's something we have to do together. Okay, I think there is a floor for questions, if there are any.
This is Shai from Limagrain. I have one comment regarding what you said about trying to express FT or suppress SP genes and use that in rootstock. Just keep in mind that when you graft, you add approximately 10 days to the first stage from seed to planting. So whatever you might be able to save in shortening flowering time, you'll be losing in the nursery work for generating the grafted plants.
We are aware of that, Say. We were aware. And we also would like to try this Cuscuta, this parasitic plant, as a more, maybe has less of an effect on delaying the transfer of the molecules to the scion. So in this case, there is no grafting, but I don't know what would be the effect of the Cuscuta on the development of the plant. We have to do that. We have to test it. We don't do it, we don't know.
Yeah, I mean, this is right. I mean, of course, if you succeed in getting a larger than 10-day anticipation, of course, you will lose 10 days by grafting, but then you will recover the 10 days and whatever else you are increasing. The main problem here is that yet we don't have anything, because the experiments just started, that really will bring us to one less generation. So going for the moment, as I said, we have about 3 generations per year in our conditions for these genotypes. And this seems to be irrespective of growth conditions. I mean, greenhouse in thick or growth chambers at Atenea. So, and I don't know what your experience is in companies. Do you have any trick? Do you have tested any trick? I'm sure you have, to shorten generation time. And do you find that these 3 months generation time is realistic? I mean, looking at the literature for Moneymaker, it looks realistic. And what we have said is a very ambitious goal to bring it down from 3 generations per year to 4 or 5. Okay, so that's 1 to 2 whole generations. So if you look at Microton, that's what it's doing. It's already doing it. And Microton is about the fastest thing that you can find. So the question is what is there in Microton besides SP, the SP mutation that's making it so much faster? If it is the dwarf phenotype, then there's no hope, because dwarf is a negative trait. You don't want to have it. Or you can play, you know, with, excuse me, there is somebody that has the microphone on. Could you mute your microphone? Thanks. So the question is, I think we have to find out what is the genetic component of Microton being so fast, and can it be exploited? That's one question. And the second question is, we notice this fact that PIMP times Lycopersicum hybrid is a little bit faster. And are there any introgressions that really give a big advantage, a big decrease in generation time from other species? There are some species that are, most species are day neutral, but there are some species in the tomato clade that are short day species, like rice, for instance. So can we exploit this to really reduce generation time? That's, in my view, the key to solving this problem. I don't think that SP or the SP family or FT by themselves will make the game, will make the trick, although I'll be happy to be wrong.
I just wanted to say that going through this genetic analysis of out of what it reduces the effect of the such a short cycling time in Microton will take far more time than we can take for the achieving the objectives. There's the deliverable that is, I think, in a couple of years now, so in 1 year and a half. But I think we have to go by the current hypothesis that working on this by combining these two SPs and FT may work for us, and we will keep trying. This is the current working hypothesis, is that it may eventually work. If not, I don't know. Of course, we so far it doesn't show that it's going to work more than we succeeded so far in these 10 days and 1 week, which is far less than expected. And as Shai indicated, the drawback of the grafting is not so good. But yeah.
Let me give you another wild speculation. We have a person in the lab that's doing a lot of microton transformation, and sometimes microton flowers in vitro. So you have these regenerated plants. You keep them there and you get in vitro flowers. So there is something in microton that makes it flower really early. And we have to find out what it is.
Yeah, we've seen this, and we also have fruits inside the containers. I mean, in vitro, this is something inherent to microtomes, and also sometimes not even microtome. Depends how fast you are transferring the thesis out to tissue culture, of course. So yeah, but we need to get it to work in real field conditions and initiate.
I think we'll get it to work, but we have to work on it.
Yeah. Any additional questions for this work package 4? Is I don't know, George, can you give a Simo mic for some people who are trying to speak? Maybe, I don't know. Can you raise your hand maybe, and Simo give you a?
Yeah, I don't have the.
Okay.
Oh yes. Okay.
I think people can activate their microphone as they like when they want to speak. Okay.
Andrea.
Okay. Giovanni, as you know, we are interested in the low density genotyping. We have been checking this salt cap selection of 384, and it appears to me that they are just SNPs chosen for covering the genome. So they are very well distributed evenly in the chromosomes, but they do not contain any of the functional SNPs that are included in salt cap. Moreover, that would be nice for some of us to have those functional genes. Moreover, we are interested in including some variations which have been selected for being connected with the style, position, phenotype. So I want to say that because maybe we can interact with the other people interested in low density genotyping. And I also would like to ask you if the check of the possibility to design primers around the genotypes is something that the company will do, or we should do it ourselves?
So the way we did it previously, I'll start with the last question. Regarding SNPs, yeah, they chose them evenly dispersed on the genome. I suspected that. The fact that they are not in gene-rich regions is not good news, because they are probably also in places where recombination is very low. So they are not so useful, let's say so. There is a complication in designing these amplicon-based SNPs, and it's that you need to have a SNP, and then you have next to it, since you have an amplicon, you have to have two strongly conserved regions. And this is not so trivial. So we have Giuseppe in our group has transformed some of our SPET SNPs into amplicon-based SNPs. And by just looking for a SNP with a significant myelin allele frequency, flanked by two very conserved regions. And if you want these to work also for introgressions, for instance, these regions have to be conserved not only between different lycopersicums, but between lycopersicum and, say, Pennelia, okay? So we have a pipeline for doing this, to take SNPs and transform them into amplicon SNPs. And we can provide this to the company. And as I said before, we have a resequencing panel of G2P salt collection with 6.4 million SNPs to select from. So it can be done. I'm not guaranteeing that all the SNPs that you sent, they will be transformable into amplicon SNPs, just because not all of them will have these conserved regions left and right to them, okay? So we might, if you are interested in a given gene, we might not use your SNP, we might use a different one that's on the same gene and that has this characteristic.
Going back to the flowering time, Giovanni, I would like to ask Danny if he remembers the accession that he showed at the beginning of Traditon when he was growing some accessions in Israel. There was a plant that he showed that was flowering and setting fruit much ahead than any other. Danny, you remember what accession was that? And
Yeah, it was a variety called Atom. Atom.
Could we do some work on that? Maybe to try to define, even if it's on a side project, to define what is the genetic basis for this early flowering? Or has work been done already, you know?
No, hasn't been. Crosses with it, we can put them in the field next year.
Yeah, if you have crosses and you have F2s, I would love, and you can phenotype them for flowering time, I would love to genotype those accessions.
Yeah.
Okay, I think it's a good idea if we can do something on those plants.
IL-21 and IL-41 are earlier than M82. And the combination of the two is really a fast one.
It's a fast one. So, how big are these ILs? How many genes are in both?
A quarter of a chromosome or something like that.
In the case of the IELs that you're mentioning, Danny, is this a difference in weeks or in months in the terms of flowering? For days?
No, we haven't looked at it, but we will in the future. Generally, there's not much difference between tomatoes in time to flowering.
Okay. Yeah,
at least in the normal conditions. You have for the short day plants, you have to apply short days, which is not always easy. You know, short days are more difficult to apply than long days, because long days you just give additional lighting with the artificial lights. Short days, it's not so easy. That's another issue with tomato, is that sometimes you just don't see photoperiodism because you don't apply the light, the right light treatment.
And Tony, and if I remember well, this Atom cultivar is actually one of the parent where the PAT2 gene was derived from. So I don't know if there is any connection with the early flowering, but maybe this is another reason to study this genotype.
Mm-hmm. PAT2 is parthenocarpic?
Yeah.
But PAT2 comes from Severianin, not from Atom.
Yeah, this means and there knows it.
The parthenocarpic line 7559 derived from Atom by Bubhe-Kosoko. Atom is one of the parents of the parthenocarpic line 75/59.
Okay, so it was that one. Okay.
Mm-hmm. Yeah. It was not PAT2, but another parthenocarpy.
Yeah, it was one of those genes, yes.
Yeah.
Another obvious candidate is the dwarf gene. It's how do you call it? Brasinosteroid biosynthesis gene. And brasinosteroids have been involved in de-etiolation, so in responses to light. So it might produce a flowering phenotype as well. It might be responsible for the very early flowering of microton.
Knocking out the brassinos in tomato is very easy. I mean, if this was a basis for early flowering, we can do this easier than anything else, probably. I don't know.
Yeah. I mean, it is known. It is a known fact that microton carries the dwarf one mutation.
Yeah, but we don't know if this is the causal gene for the phenotypic effect of flowering.
Yeah.
But if it do, what's the reason? Then targeting the Brassinos is easy. I mean, we know it works.
I would try. I would, if I was you, I would try a combined approach of targeting SP and dwarf1.
Okay, it's in the list. So, any other question for the work package 4 or discussion?
Here, this is Yulin. May I comment on this MT macrotome flowering? As Giovanni mentioned, the D locus and the SP locus, we do have F2 population. We made a lot of F2 moneymaker with macrotome for mutagenesis study. So in this case, this F2, we could genotype the D allele and SP allele if we have different category, but I have never checked the flowering time. So is that valuable to make the phenotype of this F2 if nobody has not done it yet? Now in this case, at least to see whether the flowering time is associated with the D allele or SP allele.
My main objection to that experiment is that you will get a progeny in which some plants will be very big, some plants will be very dwarf, some plants will be determinate, some plants will be not determinate. So I find it difficult to interpret the data. If you think you can do the phenotyping and correct for different plant size, somehow, then it would be worth genotype. Yes.
We could category according to the D allele, SP allele. We have marker. We have the marker selection, so we can easily genotype them at the seedling stage. So in this case, you have 4 different combination.
Yeah, and if you just need to genotype 2 or 3 genes, you just you can go for much cheaper methods, even less than €5.
No, that one we just can do it ourselves in that case, but I'm not sure about the flowering time in the F2 population, whether it's segregating or not. That I did not pay attention, but we do have F2 population available.
I would expect it to be segregating because I would expect the dwarf, more like microtome-like plants
will be earlier.
Much earlier,
yeah.
And the big ones, more moneymaker-like, to flower later.
But you would like to have a moneymaker-like plant flowering earlier. That's the genotype.
That would be the ideal.
Okay, good.
So if you, in this population, you spot a moneymaker-like plant that flowers early, then you are in business.
Okay, so I will pay attention to that, but if you can make use of this population, let me know. I'm willing to help.
Absolutely.
What Jordi was telling me that is in our virus-induced SFP lines, it's there is an effect on plant structure that correlates also with the phenotype. So, and this is independent of the virus itself. So, virus carrying GFP doesn't do it. With the virus carrying FT does it. So, the reduction on the cycle number of days from seed to seed is consistent with the plant being shorter. Okay, but so. It's a lot of many things that may be interacting. So whether every time you do a shorter plant, either with the virus or with the Brassino, whatever you have, this is something we have to look into the detail. But if you have a F2 population, I don't think it's that difficult to look at the microtome population versus F2 moneymaker. And phenotyping flowering time is very easy. Just days for the first flower or number of leaves. You can record, we record the 2 traits. Again, this has an interest, but unless it maps to the Brassino mutant, we are not going to map any fine mapping the early flowering in microtome because it's beyond the interest of the project. It will take a lot of effort.
It is beyond, but you know,
Interesting.
you have to work also for the future. Maybe at the end of this project, I will retire, but somebody else will. If you find a lead, somebody else will pick it up. You know.
Yeah. Sure. We'll do that. We are happy to continue this idea about the F2 population. If you grow them there, then we can complement this with addressing directly the dwarfing gene, or the carcinogens in a virus-induced way. Okay.
And just to add one comment, Tony and Giovanni, when we sequenced the microtome genome, we did comparison with Heinz at the genome level, and we identified the genes that have a structural variant in their promoters in microtome regarding Heinz and vice versa. So maybe it can help if you have, as Danny said, some integration line with some phenotype on some chromosomes in part. We can look if these genes are located there. Maybe it can help.
If you want to correlate these to Ulink's data, you have to compare to Moneymaker.
Moneymaker. Okay.
And Heinz, that was sequenced, if I'm not wrong, is Determinate, right?
Yes. Okay.
So it carries SP, the SP mutation.
Okay, good, nice discussion, but we need to move on if we want to have lunch in between Spain and the Dutch time, which is already probably late. So, Julien, it's your time. It's work package 5 starting now.
Yes, Simo, I will share my screen.
Okay, please.
Let me see. Do you see that?
Yes.
Okay. So in this presentation, we have a new model. I will present part of it together with all the partners. So partners, please be ready. If it's your turn, take over to present. So the package of this work package is for disease resistance. As you can see, that is emerging diseases. Oh, wait a moment, why it's not going? Yeah, we have 9 partners here. It's listed with also the persons of each partner. WU and top seat are the coordinators of these partners of this work package. And later on, and CSIC also joined because they see there's some more work can be done. So in this case, we have 10 partners in this work package. We have 3 diseases in this work package. As highlighted here, we have Cladosporum forfum, and this is the fungal diseases. It has been an old problem, but it's emerging now. And most of the tomato cultivars carrying the resistance gene CF4, CF9, but some isolate, new emerging isolate can break this resistance. And we have of new viral diseases, TOBRFV and New Delhi virus. This TOBRFV is the Tobama virus, New Delhi is the Gemina virus. And these are new emerging virus diseases. We have chosen these 3 diseases to work on. And objectives, you can see we have 5. At this moment, we are dealing with objective 1, 2, 3, 4, and 5, we need to wait for the material to be available to be used. I have to say this work package has been very active. We have every 3 months partner discussion together and update each other, also identify new actions and new directions to go on. And in this way, I would like to invite Chris Ho from Wageningen University to start with the task number 1, number 2, and number 3 even. And these are related to the objective number 1 and number 2. Chris, are you ready? Please take over.
Yes, thank you, Yulin.
Yeah.
Okay, so I started my PhD project on Harnestom in March on this topic. So next slide. So the first objective is to generate a complete overview of all QTLs and markers in tomato for tomato disease resistance genes that we know of in important diseases. So the deliverable will be a review style manuscript. So this will include genetic maps with the genetic locations of all the various resistance genes and loci. To various fungal, bacterial, viral, oomycete diseases that are relevant. So this is is currently in process, in progress, the writing and the collection of the data by various people at Wageningen University. And we expect this to be done in March. Next slide. So a small update from on behalf of UNINA. They're also contributing to this task. So they have published an article in MDPI on MBLRR diversity in tomato, which can be viewed through this the link that you see. They did an update to the plant receptor gene database. So this is now updated to version 4.0, and several tomato lines that are tolerant to Tuta absoluta, which is a insect pathogen of tomato, have been identified. And the next, yeah. So objective 5.2 is pre-breeding for durable resistance to Cladosporium. And this is divided in basically 2 tasks and 2 different deliverables. So the first task is 5.2, to achieve durable resistance by monitoring the presence of tomato CF genes, which are the resistance genes against Cladosporium in tomato cultivars that are commercially grown, and also to monitor the presence of the different avirulence genes within the Cladosporium population in tomato growing areas. And then task 5.3 is to actually achieve a durable resistance by exploiting novel CF ECP genes, and these are resistance genes that are still to be mapped, but have been discovered in various wild germplasm, and this ties into deliverable 5.4. So a bit of background. Before we started, 2 years ago, there was a study done by Carl Messerich at the University of Wageningen. He used the transcriptomics and proteomics approach to identify 70 potential effectors. So these are all short secreted proteins that are secreted by the fungus into the tomato leaf apoplast. There are currently 5 CF genes that have been cloned and that are more or to a more or lesser degree being used in tomato cultivars currently, but these are all already broken by Cladosporium races that have mutated these effector genes, and by losing the effectors, they also circumvent the recognition, which is the problem that we will try to solve. So there are also ECP effectors, which are not known to have a lot of allelic variation. So they are assumed to be present in every Cladosporium isolate. And the goal is to identify new resistance genes that recognize these conserved effectors, so that we can have resistance against all of the isolates in the field, let's say. And the picture on the right you see is from this publication from 2018, where they put these new putative effectors in a PVX construct and by means of agro-infection, various wild accessions have been tested, and the response was observed. And yeah, a lot of wild accessions, they show a response to these effectors. So it's quite obvious that there is a very wide availability of new resistances in this wild germplasm. Next slide. Oh, this is again about the first deliverable. So the overview of resistance genes. As I said, it is in progress, and yeah, it will be finished in March. The next slide. So about the deliverable 5.3, which is to get an overview of the current presence of CF and AVR genes in the tomato cultivars in growing areas. So far we have received 3 novel isolates from INRAE, from Mr. Philippe Nicot. They have been received and characterized. They were found to break the CF9 mediated resistance, and also CF2 mediated resistance was broken by these isolates, which is not a new finding. It has been observed in many isolates historically already. The French are currently undertaking a broad sampling campaign. So novel isolates are being recovered from farms which experience an infection, and these isolates will be sent to Wageningen University for characterization. And then we have our own core collection, which is consists of 87 well-characterized isolates, also historically going back to I think the 60s and the 70s even. So what is interesting about this collection is that for all of the isolates, the known AVR genes have been sequenced, and also for many of them, several ECP genes have also been sequenced already. So this contributes a lot to the deliverable. Then thirdly, we also, Pierre de Witt, so our previous shareholder at Phytopathology, who did a lot of work on this subject, he gathered, I think starting in 2015, he started the sampling campaign, and this resulted in obtaining 39 different isolates, mostly from organic farms. I believe all of them from organic farms, because in organic culture, Cladosporium is quite a problem, because there's very limited possibilities for chemical treatment to get rid of Cladosporium. These isolates have also been, the physiological race has been characterized, and the AVR genes have been sequenced, but the ECP genes still remain to be done, and this is something that we would like to do soon. Then we also agreed in work package 5 that we distribute a sample collection form, so that the partners are able to submit their infected leaf samples or novel Cladosporium isolates to Wageningen University. So a lot of information will be included, like the location and the cultivar that it was found on. It has been sent to all the work package 5 partners, so hopefully we will soon start receiving some interesting new isolates. And I also added here my email address, so for other partners that are interested, that are not included in work package 5, but that are also interested in submitting local samples, you can send me an email, and I will make sure that the sample collection form is sent to you, and you can submit your samples to Wageningen. Then regarding the CF gene screening, so we would also like to gain more knowledge about which CF genes are currently being used in the field. So we are aware that CF9 is a very popular CF gene currently, but we observe that it's being broken a lot. So we would like to perform a screen soon, which will start beginning of next year, on a to be decided collection of commercial varieties, to do a bit more broader screening, to see also if maybe some of the novel CF-ECP genes that were discovered are already introduced. So we have a good overview of what is already present and what is still worth while pursuing. The next. So a deliverable 5.4, that is about well, firstly verifying the original work from 2018 on the new CF-ECP genes, and then to also produce introgressed lines in Moneymaker background, and also map the new genes and provide molecular markers for their detection. So this is about ECP8 up to ECP17, which was identified in 2000, which were identified in 2018. We're currently doing these PVX agro-infection assays on the wild germplasm. We've identified a significantly wide range of responses, especially in Solanum peruvianum accessions. So, for example, in one accession, Solanum peruvianum is a very heterogeneous population because it's self-incompatible. So even in one accession, we already found responses to 5 of these ECP genes of Cladosporium. So we are looking at that with great interest, and we will make crosses to Moneymaker with these accessions and make interspecific hybrids of Peruvianum and Lycopersicum in order to gain F1 and F2 populations that will be screened, and then we can hopefully map these new CF-ECP genes. And because in the past it has been shown that many new Cladosporium R genes are easily broken by the pathogen simply by mutation of the corresponding effector. We decided to see if we can predict the durability of novel resistance genes. And one of the things that we will do for this is to generate CRISPR-Cas9 mediated knockouts of these effectors. So in this case, ECP8 up to ECP17. And then we can inoculate these knockout strains on susceptible plants to see what is the effect of the loss of the effector on the pathogen. And ideally, of course, we would like to find that loss of one or several of these effectors results in significantly reduced fitness and virulence, so that when in the field, when the pathogen loses it also is reduced in virulence. The next slide.
Yeah, that's your part, Chris. Thank you.
Yeah.
Now we move on to the objective number 3 and number 4 in this work package. That's dealing with the 2 viruses, and also the develop of introgress lines is carrying resistance to individual virus and also combined viruses. So these 2 viruses, as I said, one is the Gemina virus, one is the Tobama virus. And if you think about COVID-19, actually these are the viruses, looks like COVID in a tomato. So TOBRFV is rather recent. TYLCV is very already in many years in tomato. And New Delhi is in tomato more in Asia rather than in Europe. But in Europe, New Delhi virus infects cucurbits. So in this case, you can see the distribution of different viruses continentally. And in this picture, you do see the contrast. The tomato plant carry a resistant gene to the virus, grow very vigorously. If there's plant without resistant gene, you see there will be no harvest from this plant. Now you know how severe damage this virus will cause. So in this case, we work on these two viruses. I would like to invite Maria Jose from UPV Partner 5 to present their results. Maria, are you ready?
Yes, Yulin, I am ready. Thank you very much.
Yeah.
Yes, I will explain in a few slides the work done in the UPV. In the UPV, we started getting permission for using the Rugose virus in our facilities. For this purpose, we made some adaptation and modification in our climatic chambers, just to according to the regulations for the management of this virus. So we got the isolate and we multiply it to have enough quantity of inoculum to perform the experiments. The first experiment was the determination of the plant growth stage to perform the inoculation. For this purpose, we use several materials, two susceptible tomato without any gene of resistance, two experimental lines, one of them carrier of the TM1 gene, and the other one carrier of the TM22 genes, both in homozygous conditions. And also we use the hybrid Euphrates with the gene TM22 in heterozygous conditions. We use the experimental conditions, environmental conditions that we can see in the slide. And we test 3 different growth stages of the plant: cotyledonary 1, 2 true leaves, and 4 true leaves. In all cases, we got 100% of infection, regardless of the gene of resistance of the material. And the severity of the symptoms were similar regarding of the plant growth stage. So we decided to use the cotyledonary stage, to perform the following assays of inoculation. So next slide, please, Julie. So the first inoculation trial was performed with 94 accession of wild species. As you can see, we have a good representation in this trial of Solanum chilense, 64 accessions, and of Solanum abrocates, 22 accessions, and some minor quantity of accession of other species. Inoculation were performed on the 10th of September, and we evaluate symptoms at 10, 20, and 30 days post-inoculation. So the following slide, please, Julie. You can see here some of the symptoms, typical symptoms of the virus developed in different species. First in Solanum lycopersicum, the cultivated tomato, with very severe phyllimorphism and mosaics and deformation of the leaves. In Solanum chilense, we saw also some mosaics and phyllimorphism. Phyllimorphisms were most severe in Solanum chessmani, in the right part of the slide. And in Solanum abrocates, we saw also phyllimorphism and mosaics. The symptoms was a little variable also between the accession of one given species. The following slide. Here you have the results of this first trial. We represent here the mean value of the maximum symptom severity of the 5 plants that we inoculated for each accession. And you have here the results ordered by the species. Solanum chilense in the first place, Solanum chessmani, Galapagense, abrocates, and Abrocates glabratum, and the last is the cultivated tomato, Copernicum. So we can see here that most part of the accession show intermediate to severe symptoms, the blue lines, in which we represent in blue severity symptoms higher than 1. But we have also some interesting accessions that didn't show any symptoms, some of them in Chilense, but also one in Chesmani and one of Galapagense, and some more accession of Abrochaites. So next slide, please. For these accessions, we are now performing the ELISA test just to know the concentration of virus inside the plants. And we plan to grow them in a separate climatic chamber. And if we got interesting results from the ELISA test, we will cross them to cultivate the tomato. In case of Solanum chilense, which is the most distant relative of these accessions, we can use, for example, pollen mixture to help the obtaining of the F1 hybrids. So the next slide, please. You can see here some of the symptomless plants. These photographs were taken a few days ago. So plants looks healthy in comparison with others that have shown severe symptoms or intermediate symptoms. But we have to check, of course, if they have virus. Following slide, please, Jolene. So we have started already with a second trial. In this case, we have inoculated a little more than 100 accessions, focusing more in Solanum peruvianum and Solanum pimpinifolium, but also some other species, and Solanum arcanum, just to have a representation of all white relatives. And the inoculation were performed a few days ago, and approximately in a month, we will have the results for this trial. Next slide, please. We plan for this year to test 78 more white relatives to finish the 300 accessions that we have to test of white relatives in this task, and also to select 100 accessions from the Traditon project, from the core collection of the Traditon project, 100 from the G2P project, and 75 from the Resolve project. So we will do this inoculation along this second year of the project. Thank you very much for your attention. This is all from now, from UPV.
Thank you, Maria, for the nice progress. And we move on, still with TOBRF way. There's more fun, more mapping already with Huji from Danny Zamir. Danny, are you there?
Yeah.
Okay. Could you see the slides?
Yeah.
Shall I move on, or you explain these slides?
Please move forward.
Yeah.
So about 10 years ago, we started constructing a new population that involves an accession of Solanum penellae, not LA716, but LA5240. And we made backcross inbred line population. So we did wild species cross to the Lea, which is a processing tomato type, then 2 backcrosses, and self until F6. And we have 1,500 line in this population. So the idea is to obtain a population that is very saturated with the markers. Next slide. Well, it turns out that the penellae parent is somewhat resistant to the virus. So we could score in the population when we grew it 2 or 3 years ago, we could score the phenotype of the virus from 1 to 4. So the symptoms are symptoms in the leaves, where 4 is a healthy one. And in the fruit, there are these patches that make for an ugly tomato. And we don't have the right picture here to show the brown rugose, but next time I'll change it. So that's our scoring methodology. And next slide, we made in G2P Sol, we mapped the population with the SPET system that I must admit I was very skeptical at the beginning, but Giovanni persuaded me to go this way, and it's really a nice, very nice system. So we have mapping of Lea population, the determinate population, and we also have it in indeterminate population, altogether about 2,000 backcross inbred line genotypes with complete good 10,000 if markers. Next slide. So it turns out that when we map the resistant to the bills of there, we map it a very strong peak on chromosome 2. And well, chromosome 2 has only one arm. So on this arm, it's located. Next slide. And in a different background, we could see that there are 3 QTL detected. The strongest one is QTLB. So on QTLB, you could see that the cultivated tomato as the plants that are homozygous for the cultivated tomato allele has is more susceptible than plants that carry the Pennelli allele. In fact, it's a transformation of the ELISA score that was done. So this is the same gene for resistant, and there are 2 loci for susceptibility, A and C. So you could see the allele of Pennelli is more susceptible than the cultivated tomato allele. Next slide. So here, so that it landed the window that defined the resistant landed very close, or was in the TM1 region, the gene that confers resistant to Fusarium, to TMV, and was replaced by TM2A. So we ordered from Davis the TM2 resistant lines, and you could see that both of them are resistant, and you to the tomato brown rugose fruit virus, and also Solanum Pennelli is, and also finally the line that carries chromosome 2 from Solanum Pennelli. So this is the gene for resistant. Next slide. So it's now we are in mapping. I think it's down to, if you want to say that this the gene, then you need to map it there, or at least to do CRISPR on the gene. We are going with a mapping, and we map it very closely. We could show that this TM1 gene confers resistance, particularly to the leaf tissue of tomatoes from the tomato brown rugose virus. That's it.
Thank you, Danny. Nice result. Now we go to top seed. Liran, are you there?
Yeah, I'm here. Can you hear me?
Yes.
All right, great. Thanks, Yuri. So my name is Liron. I'm a researcher at Top Seeds International. We're a seed company mostly focused on vegetable seeds. And we are, as part of work package 5, our role in Ernestom is to screen for TOBRFA resistance, try to find new resistance sources. And we work in close collaboration with Danny Zamir's lab. Danny's lab has a large exotic germplasm collection. And Danny found that, so he shares with us some of this collection for our screens, some of the germplasm. We use our own germplasm for the screens. So Danny found that he talked earlier about Solanum penelli. He found that Solanum penelli LA716 has a strong resistance to TOBRFA, the virus. And this resistance, as he said, is supposed to be stronger than what was found before. So next slide, please. So Danny shared with us the seeds of this population. Some of you may know this accession. This is the classical Penelli accession that was used for many years now to identify and map new traits, all kinds of traits. And so Danny shared with us this population, and we started using it for our TOBRFA screens. Next slide, please. Yeah, next. Oh, by the way, I just want to mention that this slide, as opposed to the old LA716 population, IL population, the introgression line population that was composed of about 76 lines, this population is much larger, composed of about 650 lines, and this allows for much higher resolution because the introgressions from Penelli are much smaller, and with that of overlap between the introgressions. So it's a very useful tool for mapping new traits. Next slide, please. Yeah. So instead of screening the entire population, which is very big, we generated a few sets of bills that give full coverage of the Penelli genome. Next slide, please. So, and you next. So we use these sets for the screens. This is our TOBRFA screen facility, inoculation facility dedicated only for TOBRFA screens. It's very nice. Everything is automatic. We can do a large amount of screening relatively fast. So basically, we saw the seeds, and at first true leaf stage, we inoculate the plants, usually the cotyledons, do a couple of sequential inoculations in order to ensure very high infection rate. Usually in TOBRFA, you don't really need it because the infection rate is so high anyway, but we do it, and then we grow the plants for a few weeks more, usually 3 or 4 weeks. We score the plants for symptoms, and then we filter out the plants that show the highest amount of symptoms. We leave the plants that show potential. We grow them for a little bit more, usually 2 weeks, score them again, and then collect leaves from all of these plants for ELISA. So this is...
Sorry, too fast.
So this is what we did basically for over 100 bill families with almost a full coverage of the Solanum penelli genome. And we basically, with regard to symptoms, we basically found symptoms on all of them. On some we found more symptoms, on some we found less symptoms. When you deal with the bills of this type, as you deal with other wild species, you know, they look different anyway. So the phenotyping or the scoring is more challenging. But anyway, we found symptoms on all of them. But still, we collected leaf tissues from the ones that show the least amount of symptoms and did ELISA. And we found high levels of virus in all of them. Some of them, you may be wondering, what about the wild parent? So, well, the results here were a little bit mixed. We tested it twice. The first set, the Penella showed looked very nice. It had a very low levels of virus. It was practically clean. So it was nice, and it was very encouraging. But in the second screen, the wild parent had the same amount of virus as as other plants. So it looks like there is some potential there. It's not a full immunity, but it's still something to investigate. We use Moneymaker as the sensitive control. It's very sensitive. Also M82 as the other parent of this population was also found to be very sensitive. And all the bills showed high levels of virus. There was one bill, if you look at the second from the right, that sometimes there were a few plants in this family that had lower levels of the virus. Not surprisingly, this bill has an introgression in the TM1 region. So it looks like the TM1 from this succession also has some effect. But I have to say that we looked at other bills in this population that also have introgressions in TM1, and some of them were highly symptomatic. So I don't, there are probably differences between different alleles of TM1 from different accessions. It looks like this TM1 has some effect, but it's not what causing the wild parent to have stronger resistance. Also, this TM1 seems to be a little bit weaker than the classical TM1 from Habrokaitis, which is, according to our experience, is better. Also, it doesn't give full resistance, but it reduces the symptoms dramatically. Next slide, please. So just to conclude the findings in this experiment, overall, we screened above 100 bill families, and none was found to be resistant or completely symptomless to TOBRFV. The Penella LA716 appears to have stronger resistance to TOBRFV, but it's not immune to the virus. It looks like the resistance here is more complex and not governed by a single gene. This means that we might not be able to use the bills to identify it. And maybe we'll have to generate some kind of an F2 population in order to look at recessive QTLs and other epistatic relationships. And as a follow-up experiment, we cross these bills or some of these bills to TM1 from Habrokaitis. And the idea here is to see if we can combine forces, from two different wild species. So we have TM1 from Habrokaitis. Each allele is a little bit different. So we want to see if we can find some gene in Penella that maybe by binding to its promoter or with some other epistatic relationship will enhance the TM1 effect and maybe enable it to give much stronger resistance than it gives now. More ideas that we have. Another idea that we have for the future is that resistance for the virus is very difficult to find, but sensitivity is everywhere. So we also think about maybe mapping, trying to map sensitivity genes. So this is also something that we hope to do in the future. Thank you.
Yeah, thank you. And now we move to the next one. Gang Hao from MVCRI. Are you ready, Gang Hao?
Yes, I'm ready. Do you hear me?
Yes.
Okay, thank you. So I'm from Maritza Vegetable Crops Research Institute, and we are engaged also in this task for identification of resistance to tomato brown rugose fruit virus. We have planned to use about 500 accessions, mainly Solanum lycopersicum. And this collection is consisted from also Bulgarian local accession, as well as those from foreign accessions. So till now, we have provided seats for 189 accessions, and basically 136 we screened. As you see on the slide, 113 are from Bulgaria, from these 189, and 18 of them are from G2P Soul collection. These are only from Bulgaria. And also from the foreign one, we chose only one. This is, I'll mention this is a bit later about this accession. So in order to perform the work, we issued permission from the local phytosanitary office that was done successfully. They are visiting us on a regular basis. So work is in progress. Also, we've provided the isolate from Israel for screening purposes and from DSMZ. So next slide, please. Similarly to the other colleagues, we perform our experiments in growth chambers. So this is with the controlled temperature, about 22, 25 degrees, and light regime is 14 to 10 light dark period. So we grow the plants in small pots, single pots, and also usually 10-15 plants from accession. We inoculate them at stage first through leaves, and we inoculate only the cotyledons. So the infection is pretty concentrated, and we inoculate them only once. And the first symptoms we got about 10 days after inoculation. So we score them at 15th and 30th day. You may go to the next slide. So here I present just 3 accessions that are, I would say, they have some degree of tolerance at 15 days after inoculation and 30 days after inoculation. Although in the 15 days, they seem pretty symptomless. On the 30th, we see some slight symptoms. The first 2, accession 24 and 25, are from Bulgaria. They are indeterminate tomato, salad type. While the third one, this is 38-2. This comes from, actually, this is from G2P Soul. I've given the G2P Soul number, LA0477 from Peru. And it was reported as one that is resistant. Unfortunately, in our experiments, we find that only on the 15 days after inoculation, it's symptomless. But after that, on the 30th, appears to be with slight symptoms. ELISA tests that we performed proved this, and actually the amount of the virus is 3 to 5 times higher than the negative control. In other words, infection propagates very easily in these accessions, although the symptoms might be not so severe compared to the control, because we use moneymaker as a control. And the typical symptoms are shoestring on leaves, blisters. Although, if we look at the other sensitive accessions, basically symptoms were connected with shoestring and blisters, or leaf bending, downward bending of leaves, and in some cases only slight mosaic, But nonetheless, they have pretty high amount of the virus, like 8-9 times above the healthy control. We have some more accessions to screen. they're basically Solanum lycopersicum. If I compare the germplasm of other colleagues, they target mainly the wild types. So these are our next plans to finish screening the collection. Thank you.
Thank you, Ganho. Yeah, Mara, you have 1 slide or 2 slides to present.
Okay.
Yeah.
It's a very quickly
presentation.
So I decided to participate to this task because 2 years ago, I had a segregating population in the field that was attacked from TOBR virus. And more or less the 44% of the individuals were not attacked without symptoms. So I decided if to test by chance if there was a resistance there. And so we test this population with this strain TOB621. But unfortunately, the virus infected the plant at most of them already at 7 days. We saw some symptoms, and 11 days the symptoms become more present, and we make also some immunostrip at that time. All were positive. At 21 days after inoculation, we could see already that the plant have some senescence with the chlorotic and necrotic spot. So just to give you an idea what we got, these are the symptoms that we saw at 7 days. These are the strips that were positive, and these are the symptoms that come out after 21 days. They are not very strong as the other partners, but the virus were there.
Thanks, Mara. Yeah, so it means the resistance is not confirmed.
No, it was not confirmed.
No, okay, yeah. Now we move on to the New Delhi virus or the TYLCV with Peter.
Hello, good morning, everybody.
Hi.
So yeah, our work in task 5.5 was to put together a set of tomato lines representing different combinations of TY genes, either single, two-way, or three-way, to multiply those lines, to treat the seed and test them so that they could be sent to EU countries or other recipients without problems. We are also designed a testing protocol, including a scale, so everybody measures disease severity using the same scale so the results can be compared. So the idea then is that the cooperators will conduct the trials under high begamovirus pressure at their respective locations, score the plants for disease severity, provide the data to us, and hopefully provide samples to us so that we can identify the specific begamoviruses in those trials. Next, please. So we conducted a preliminary trial here in Shanghua, Taiwan, in the southern part of the island. So the set included 11 lines. I'll show you those in a minute, including a susceptible Czech called Tanya. Entries were grown in a randomized complete block with 2 reps and 12 plants per plot. And we evaluated each plant separately, or scored each plant separately, and then averaged the plot means. So the trial was transplanted in mid-April on our farm. So this is really the period when whitefly populations are high, and we're pretty reliably can get a very high begamovirus pressure. And then the plants were evaluated using the scale twice on the 12th and 26th of May. So you can see this is our 1 through 6 scale that we use. We intended to continue the trial into June, but the trial was flooded. We had a drought, and then it turned into a flood once we got into June. Next, please. These are the 11 lines, 11 entries, and you can see they range from having no TY gene to single TY genes to 2 and 3 combinations of TY genes. We also included one line. It's one of our breeding lines, 4018I, that doesn't light up for any of the TY genes, but it has shown resistance not only in Taiwan, but other locations. These are the severity scores from the second evaluation. So it's pretty straightforward. You can see that in one group you have Tanya, the susceptible, and the line with TY2. And then all the others are grouped together with no symptoms or very mild symptoms. We looked at which viruses were in the trial. You can see there, well, in this part of the island or in Taiwan, we have mainly tomato yellow leaf curl Thailand virus, which is a quite aggressive bipartite begamovirus. That's not only here, but also, of course, in Thailand and other parts of East Asia. So most plants were infected with that one. And also Lisianthus leaf curl virus, which is a new virus for me. This is the first time we've encountered this virus in our trials. This one is a monopartite virus, but also infected most of the plants. And in addition to the begamoviruses, we also had tomato chlorosis virus. So that's pretty standard in our field trials because we have lots of whiteflies, which also vector not only the begamoviruses, but the Crini viruses as well. And we mainly have tomato chlorosis virus. Next, please. So this is the status of our shipments to different collaborators. So you can see the organizations here on the left-hand column and the different locations that we're targeting to do the testing in and the months of the trials will be conducted. So in most cases, well, actually, we've shipped to 4 different recipients. The shipments to Jordan, Spain, Malaysia have been shipped. The shipment to India will happen next week, and the others are more or less in progress. So things are starting to move along. The shipment to India has to go to our group, and we have a group in South Asia. Those seeds have to go through post-entry quarantine, so they have to be grown in a greenhouse. We'll multiply the seeds there, and then we'll send them to Enza and probably some other Indian seed companies. It's very important that we do the testing in North India because that's where we're pretty sure to find tomato leaf curl New Delhi virus. Shipment to France was a little bit tricky, and we're using a Rolig, which is an agent. It's not possible. That's the route we're going. So that's it from me. Thank you.
Thank you, Peter. Now, then I will represent Samuel Otto for Mina because for this task point 5 and 6 is not started yet because, as we said, we need to have the plant material to arrange the field conditions or other conditions to do the test. So this task will be planned in next year or the year after. So that's the progress of task 5.5 and 5.6. Tony. Sorry.
No, yes. Thank you for me.
Oh, sorry, Mina. Oh, maybe I misunderstood. Yeah. Oh, sorry, Mina. Sorry. Please update. Yeah, sorry. I think I have another one in mind. Yeah.
No problem.
But do you have any addition to what I said?
No.
Okay.
We have made the request for seeds.
From Peter to get the seeds.
Yes.
Yeah. Okay. Now we go. Tony, do you want to update these slides?
I don't think there is anything else to add. Just to summarize what Peter said about we participating in, well, Rafael Fernandez, who is also attending the call today, evaluating this for Tobago virus in a facility that they have down there at the CSIC facilities in Malaga. And then here, Jose Antonio, that is helping Work Package 4 also. Here, he could help also in sequencing some variants, but maybe we don't do so as this was to be done in collaboration with MARA, because they may detect some new variants of the Burgos virus from Italy that we volunteer to sequence. But if they use the service that Gancho also used already, because there is a project, a EU-funded project to do so, maybe we don't need to do it, but we are open to help in that. And also I'm helping coordinating this, but Peter already described this very nicely, so not much to add.
Yeah. Thank you. Yeah, that's more or less the summary. I will quickly go through it. So as you can see that in this work package, the main focus is identify resistance sources. Once it's identified, we will make a mapping population to find the causal genes, and then to make the integration lines, if possible, also combine different resistance together. So we are quite in a good progress. I think we identified resources for TOBRF resistance, and the combined TY gene lines will be provided. Of course, screening will go on. Then that will be naturally follow up for mapping and cloning of the gene. That's the task. And for this one, Peter already presented it, and we will receive the seeds and perform the experiment to test these lines. So everything is in progress, and this one again, it's showing that will be second year or third year we will carry out once we receive the material. So the work package 5 is in a good progress, and with that we go to the deliverables. We have 2 in the month 18, as Chris already mentioned. That's the overview, that's the report form for the disease resistance in tomato. We will provide it, and also the effector markers for the CF gene, and we will summarize it and also provide it as a report. Yeah. With this, I would like to acknowledge all the partners for their support to me for the work package 5. Thank you all.
Okay, the floor is open for questions. If there's any question or discussion for work package 5. No questions? Nothing to discuss? Or your stomach is grumbling for food? Maybe he wants to speak himself. Okay, so if there is no question, tomorrow at the end of the sessions, we will have time for anything that rises and we want to discuss. But as a wrap up, I think just to indicate that it seems that we are making good progress in all the work package described today. Work package 2 reminds you that we need your collaboration for the dissemination, for the Twitter account activity, and so on. Work package 3, there are templates and data that need to be filled, and there is need for your collaboration also. In work package 4, good progress, but there is a need to amend a couple of things that they want in the grant agreement, and we need to discuss it with the project officer. And also we need to discuss some issues on the budget that is not enough to fill the request of sequencing and genotyping, and this we can discuss tomorrow. In work package 5, means that we have made very good progress in all the tasks, and for the brown fruit rugose, means that it seems that there are some sources, potential sources for new resistances. Seems that the TM1 is coming up like a good source, but there is something more, as several panels showed. For the Cladosporium fulvum, need feedback from some of you, from companies about the resistances that they're using, and from other panels about new strains of Cladosporium fulvum, or sources of materials or samples that they can analyze to identify new variants. I think, well, that was it. So thank you very much. Have a good lunch. And don't forget that tomorrow we start at 8, not at 8:30, okay? Today was 8:30, sorry, for those that were up and already connected at 8. So please connect a little bit earlier than 8, so we make sure that we can start good at 8 a.m., okay? And think about possible issues for discussion at the end of the sessions. And then that's it. So have a nice lunch, and see you tomorrow. Thank you very much.
Bye-bye.
Thank you.
Bye-bye. Bye-bye.
Bye.
Bye.